14 years after. Again, those of you following the news, an incredible earthquake hit Turkey a couple weeks ago, in fact, and to see that there is a comeback possible is, I think, incredibly important. Thank you for everybody for being here, coming here for l'Aquila. Thank you everybody who really showed up for Turkey as well, but also for software architecture. I think it's a comeback for software architecture as well. So that's kind of the theme of today, because we're bringing back industry and software architecture research together, and that's going to be the part of the day today. So what I'm going to do is I'm going to walk you through a couple of the highlights of today, as well as some reminders, and then we'll kick off with our keynote. We forgot, because we were so excited to be in person, that there's a social media and online program as well, components, so please follow the ICSA conference Twitter, tweet some of the observations that you have, so those who cannot be here get exposure to the conversations that we're having. And we also have a Slack channel. Join our Slack channel. This does not have to be only for those who are not here, but for other conversations that you might start to initiate. The Slack information is also on our website, but I'll leave this here for about 10 seconds. Yesterday we were reflecting, why isn't anybody tweeting? Because we didn't make a big deal out of it, right? So, all right, so today's theme is the Industry Day. And our position is that anything we do in research, if it doesn't impact practice, it really is not probably the right kind of work we're doing. So we do not necessarily separate research and practice from each other. However, we are also very cautious and aware of the fact that industry may not be able to dedicate as much time. So that's why today is dedicated as an Industry Day. The topics chosen today really combine some of the work that is more in the forefront of industry challenges, like, for example, a lot of microservices talk will be again continuing today, but also what brings research together. But I want to spend a couple minutes also talking about the industry track submissions, because we do also welcome submissions from those who are practicing software architecture, the challenges they see, how they use some of the software architecture research and combine with their work. These numbers may not look impressive to you, but 25 submissions is pretty good for a software architecture in practice track. This was also further endorsements for us that we should continue to really work on our software architecture focused practices and bring it together with industry. So we had 25 submissions. Ironically, we thought we're going to make these submissions lightweight, only abstracts and presentations for industry, so they would show up. That we had only one submission, presentation submitted. That was a very good submission. Unfortunately, our colleague could not figure it out with his company, so could not be here. But then the 10 accepted papers are throughout the program distributed. A significant number of them are today. So this is also a plea and a call. Those of you who are from industry, there are lightweight ways to present your work and also create those conversations. In the upcoming versions of ICSA, we will continue the lightweight submissions with presentations. And if we can help convince your organizations, we'll do that in terms of when we can maybe allocate your sessions. Maybe we can help you craft the presentations. This is really about not making it a high bar to enter, but making it the correct bar and the correct conversations. And we already talked about the rest of the presentations yesterday. So a little overview of today. We have going to be kicking off with our industry keynote pretty soon. We have 2 working sessions across the program. There are 5 working sessions, but the 2 today are in particular led by industry. And I encourage you to attend. And one is focusing on agile and software architecture and those challenges. And the other one is focusing on automotive software, embedded software, and architecture challenges. So I know everybody will want to be in both, but that was our goal. People want to be in multiple sessions. The topics are also aimed to be in the intersection of research and practice. And that's also how we put some of the paper presentations. It's a blended program. Yes, there are industry authors, but there are also technical authors, journal first authors, because they focus on some of those challenges in the interaction. And in the afternoon, we'll be having a panel focusing on educating the next generation of software architects. This is a pain point of mine. If you are in the hiring business of software architects, we can all share our misery. They're very difficult to find. They're very expensive. They're very difficult to educate. It's similarly true for students. If you're a student sitting in the seat if you want to go to industry or into academia, I think you'll get a lot of this as well. And we have quite a well lineup for the panel. And I will not take a lot of floor because I will introduce Tatiana next, but a plea to you all is we all have the responsibility to make these connections. If we're all software architects, or I think that our work is in software architects, we better not categorize ourselves as researchers and practitioners, but categorize ourselves as software architects and think about how the work we do is changing the practice. And I think that's really a plea today, tomorrow, and when you go back to your work. How do these connections happen? What are the challenges that really require more research, more data, more empirical practice? What are the challenges that need techniques, as well as what are the success stories, what are the things that work, and what are the things that do not work? And I think without those conversations, we will not be able to make progress. A reminder about the publication, the proceedings, if you want to access them. This information is also available on your programs in your badges. And I think that's all I have. Enjoy the day. And with that, I'll introduce Patricia, who's going to introduce our keynote.
Thank you very much, Ipek. So I have the great honor to introduce engineer Tatiana Rizzante. I know Tatiana for almost 30 years. She did a master thesis in the same group, a research group. I was at the time a PhD student at Polytechnic University in Turin, where she earned a master's degree in computer engineering. Her career since then is amazing. She is a CEO of Reply, which counts over 12,500 employees and a revenue of over 1,500 million euros last year. Reply provides digital services for healthcare, energy, retail, manufacturing, financial, just to mention a few, in application domain like intelligent automation, cloud provisioning, security operation. As CEO, she's responsible for the full range of services offered by the group and for building the Reply presence in Europe, US, Brazil, and China. Since February 2020, Tatiana is also an independent council member of the JEDI Gruppo Editoriale SPA, #1 digital media joint stock company in Italy. And in April 2022, she was made an independent council member of the Italian Stock Exchange. The vision, competence, and impact she brings to the digitalization of all sectors in Italy and internationally makes her an incredible force and a role model for all genders to invest in informatics for their professional futures. So Tatiana, please join us. Thank you for being here.
Thank you. Can I have so that I can move, or you prefer me to stand? Okay, I stand. Okay. Ok. Grazie. Grazie. Should be working? Yes. Okay, thank you. First of all, thank you, Patricia. Too good. To introduce a bit, as Patricia was perfect, Reply started at the end of the 90s. So we are one of the, let's say, European next generation IT services company that started with basically with the web. Now we just gave the numbers, the new numbers. So 14,000 people, a couple of billions of revenues. Mostly in Europe, so less than 50% now is Italy. The rest is mainly Europe, with 10% in US, mainly Seattle and Atlanta, Chicago. Okay, we work for large enterprises. We build services and products for large enterprises. So we are not outsourcing application management or managed services type of companies, and we provide a full range of services. From design, experience design, product design, and so on, to actually software making, to eventually organizational change, cybersec, and all the related services that are used together with making a new product or service. Every product or service, of course, is a software product and service today. Now, I show you a little bit of a video, which is of the digital experience team. That means the people that do the design and communication part, because it's the most fancy to see. Software people are a little bit more, let's say, less nice in terms of videos, but it gives you an idea of the type of customers we work with. If I'm able to go on, maybe. Okay, let's try this way. Okay.
Yeah. I'm ready to play now. Put me in the game now. I came here to prove it. I'm ready to do it. I can't be afraid now. Put me on the stage now. I'm ready to rage now. I feel like an animal stuck in a cage and I'm ready to break out. My time, my time. None of you people can tell me to stop. This time, like the last time, you better get ready to race to the top. Ready to do this, show you what the truth is. I step on the field, it's time to get real. I'm feeling so ruthless. My time. None of you people can tell me to stop. Lower the lights down. Hand over my crown. Hand over my heart. I do this for my town. I do this for my crowd. So turn me up real loud. My time. None of you people can tell me to stop. Yeah. So what are you afraid of? Those feelings are made of. Get in the game, your moment of fame. Show them what you made of. It's time that we stand up. It's time that we man up. For anyone asking who is the best, we putting our hands up. My time. Nothing can keep me from reaching the top. This time, like the last time, I'm moving so fast, I'm ready to ride. I'm ready to throw down. It's time for the showdown. I'm ready to rise. Don't be surprised, I'll take on the world now. My time. None of you people can tell me to stop. My town, my crown. We know what it takes to be reaching the top. We reaching the top. We reaching the top. We know what it takes to be reaching the top.
Okay, this is 25%, 30% of the business, so the design and digital experience part. Actually, to give a little bit of a background, let's say 40% is, of course, in software making. I've got a little bit of a, okay, this is working. So, and actually, I'm a software architect, or I consider myself a software architect. I've always considered myself a software architect. Now, I'm not used to give a presentation to the academy. I think it's the first one after my thesis, so I'm not structured. Please interrupt me. So, but I'm trying to just to hopefully give you the perspective of what I see every day working with our customers. So, as a background, I started in '95. This is the project we were working on. The idea it was to model a software process flow, entities, and so on, produce automatically the software organization, and validate formally before even building the software. So a view of a time where the world was going much slower. And when I started working, actually, the world was still at the beginning of the internet. This was my first project, object-oriented architecture. So the system for monitoring the gas infrastructure, the Italian gas infrastructure. They were moving from traditional modem to an object-oriented modeling. One code base, relatively simple type of words. Already the same year, another project was at the dying moment of the client-server architectures. So this was for the largest broadcaster in Italy at the time, which is Mediaset. It was an ActiveX-based project. Microsoft ActiveX was a technology to build a small software component inside the web browser that was connecting to the web server on the back. And that actually was the dying breath of the client-server architecture. Move forward a few years, and we were all working on software-oriented architecture. So, okay, We have the web. We start to have application server on the back, no more web servers, but application server. We start to have componentized architecture and the problem of orchestrating these components. From one code base, a simple application, a simple word, ERP, and a few other verticals, enterprises suddenly found themselves out with a lot of small applications here and there. It was the period of the hubs. So the idea of orchestrating, building this workflow of data and so on, and orchestrate the application world from a central hub. This is an example of an architecture I worked on. It was a typical telco building and CRM architecture of the time. 2008, the first cloud project. It was EC2 and SC3. So Amazon Web Services, I put you a screenshot of the time. Amazon Web Services was a service on the Amazon.com. And actually it was 2008 is the date in which we started our first company focused on AWS. A few years before, for some of you, you may remember, everybody was talking about utility computing, but there was really nothing out there. 2008, Amazon came up with these two services, EC2 and S3, which, very simple interface, you could provision machines and build your own software. Since we were doing a lot of new product development, if you are a customer, you have the problem of you are building your products, you are planning for scaling up, but you don't know if you will be successful or not. At the time, I remember the first project, it was for a kind of social network type of service that a customer was building. We went to HP. We asked them the prices for the infrastructure for a medium scale up. If it's successful, what happens? And the price was huge. And so the point was, okay, the customer was like, we will not do it. So one of our people in the team said, there is this new services by Amazon, it may work. And we said, okay, what is the price? I still remember it, it was 10K. And we said, to start. It's like, done deal. I mean, the thing was, the discussion was finished at that moment. So, and this is how actually this took momentum, with taking all those startups and services that were not so sure about, the actual scaling up. 2014, we kept working on building a system on the cloud. So more than bringing system to the cloud, it was building the new there. The industry started to come up with a lot of new services, and the architecture, as you see by this picture, I know that they are all different graphics, but that's a word out there, start to take a different shape. So pieces, clouds, boxes that get connected in a not so organized and orchestrated manner. Still a role by the integration bus or some form of integration, but much more loose. 2015, 2022, the cloud is basically the platform and the architecture for everything new, and we've been working in bringing, all the industry has been working in bringing a lot of the data centers, not all, and we are still continuing today, it's the long tail, onto the cloud. Architecture are getting more and more complex, because, of course, from the beginning where you had mainly one cloud, you build a new service, you choose one cloud. You have the problem of data, you still have the problem of data, and this is a big topic we could open. Now we are almost by default in a multi-cloud environment when we build new. So in the infrastructure, not necessarily, but when you make, you're always in a multi-cloud environment. Sometimes with abstracting platform like Red Hat, OpenShift, but in most cases, actually, you consume directly the service offered by the platform, because otherwise, always using an abstracting platform would mean remaking everything from scratch. So the world in which we are working now is a world of a big platform, distributed services that you can consume and you can use to make your own architecture. And this is how all of us build software in this moment. Now, of course, in this world, what is the problem we face every time? This is what I'm trying to at least tell me. So if you know I'm saying something obvious, please interrupt me and so on. One big problem that I will not talk about today is the data. And I will not talk about it in any way because it's simply too big. Because, of course, behind this architecture at the end, you have just two things, the data and the software architecture. So I focus more on the software architecture than the data. But in the reality, every time today you do something, there is always a discussion on where to put the data, how to make the integration, and so on and so forth. And there is no answer, none at all, and also, in my opinion, no clear view of what will be in a few years. Every cloud vendor is battling for us to put the data in their own data cloud, whether it's Amazon, Google, or even Salesforce is pushing on its own data cloud, SAP, and so on and so forth. So every enterprise ends up having data in multiple spaces. And of course, you have this fluid data architecture. We talk about pipelines. We don't talk anymore about data integration. So a kind of fluid view of data that move across this cloud and are consumed by the application. With a lot of new product vendor emerging for monitoring this data, managing this data, put them into safety mode, and so on and so forth. So this is probably the biggest and most growing area of all ICT in this moment. In terms of software architecture, the other big topic is how do you architect that, an application and a system today. You have your own legacy world. It doesn't matter if it's on a cloud on your data center that is made of big blocks and for sure a hub somewhere. And then you have the world of thousands of services available on the cloud platform, and you want to make your own application. So you end up in a world that is incredibly fragmented. I know that you had talks about microservices, and you mentioned that you will have more talks about microservices. Microservices is the reality for building software architecture today. And now I say something, and I don't think that is actually seen as a big problem by most of our teams and by most of our customers. In the sense that it's accepted that it is how you have to work, again, because this is how the world gives you pieces of software to consume. Because all the tools that you use to build software today, all the tool chains and CI/CD chains and so on and so forth, are built for managing and assembling and so on microservices. So a few years back, I was thinking that that would have become a big problem, and this type of architecture will eventually collapse. I changed completely my mind in the past year. I think that we will soon go past this type of architecture, and we even forget the existence of microservices. And in this moment, actually enterprises are pretty comfortable with that. I mean, they have much more problem with data than with microservices architecture. So, every application is built with this type of architecture in mind. Every application is built on a CI/CD platform. And the number of microservices is actually scaling up pretty fast inside enterprises. And they are not doing many projects in terms of managing and this type of services. I mean, enterprises manage application, manage product. They don't really care about managing the microservices. This is kind of seen a problem of the single application, not an enterprise problem. I don't know if it makes sense to you in terms of this. I put you these to give you an idea of the size of the number of microservices that we normally find. So if you look at a platform like AWS, of course, it's enormous. If you look at the software-defined car platform, you go in the thousands. And of course, an accordingly large number of people working on them. Netflix, that was the pioneer of this type of architecture, this type of size. So the industry is coming up with its own way to deal with this complexity. One way is packaging microservices into apps, so apps suites. So if you see all the big vendors like Salesforce, SAP, and so on, they are talking about composable applications. So the big suites or whoever sell application are building architecture that allow you to put and to develop in microservices and put it under their own kind of management. Another stream of work is about decentralized applications. So there starts to be platforms out there that allow you, if you want to build your own completely custom software, so you're not using package, but you're more into the build side, that allow you to manage them with distributed blockchain type of networks and architecture to manage these microservices, and you start to find a quite good product out there. Of course, you still have a software as a service approach, so you can have composable apps in which you can still be in charge of part of your architecture, or you can simply work on package. And more you see a software as a service approach also on vertical application and so on. So that tends to hide this type of complexity to customers. I also highlighted the topic of composable infrastructure because, of course, when you talk about microservices, and let's suppose that we are not talking about an IT system, but we are, for example, in a product space, the software defined car of before. In this time, you are working at a lower level. Of course, one of the big topics is where do you run it? Where do you run your microservices? On which platform? Do you put them where the data are? Or you bridge the microservice with pipeline because you want centralized data and so on and so forth. And how do you make sure that there are enough infrastructure resources for that microservices and so on and so forth? Well, currently, in the most cases, the edge in the industry is starting to put the logic of provisioning of an infrastructure in the software itself. So we are basically taking this problem out of the shelf with kind of changing the approach. Is the software itself that know how to position what it needs, and eventually you abstract there the logic for provisioning the infrastructure. That allows you also to move easily the microservices and eventually just build the adaptation to the different layer, so without necessarily touching the microservice itself. So anyhow, this is a very moving field with the industry coming up with very different tools and solutions. But again, it's not a very hot topic from the customer in, oh God, how we will manage all these microservices out there? Yes, there are the architecture teams in the customer that of course are working on that. But most of it is being addressed so rapidly by the platform and by the vendors that most of the large customers are really working inside application type of views and platform, and not much trying to rebuild the type of monitoring and governance that they had previously. I don't know if it makes sense. Oh, sorry, I put some numbers to give you an idea of the size of these markets and the percentage of growth of the different areas and approaches. What customers are much more concerned about when you talk about microservices is the organization of work, actually, and the methodologies to build and maintain application. So currently we are coming out from the SecDevOps type of approach, and everybody is wondering how to cope with this next phase, because Agile and SecDevOps methods goes well and work well if you look inside a single silo. So you have your application, you're building your products, and so on and so forth. And actually they work well for the first run. They are actually terrible when you start to have multiple interconnected software systems, and they are actually terrible in the long-term life cycle. To make a simple example, you end up having tons of CI/CD chains, tons. I mean, the average enterprise has already, I think, without, sometimes knowing it, sometimes without knowing, hundreds of them, not tens, hundreds. Because in most cases, every software stream, every software project, you're building a billing system, an order manager, I don't care, whatever it is, a new cart for the e-commerce or whatever, will have its own CI/CD. Because the team will build its own CI/CD. It depends on the cloud that you are working on. It depends, or on the abstraction layer you're working on. It depends on the software as a service platform you're working on. So if you work as an extension of Salesforce.com, you will have you will deploy a CI/CD on the Salesforce.com cloud. If you're working on AWS to build an IoT backend on AWS, you will have one or more, depending on how big the project is, CI/CD on AWS, and so on and so forth. Which is not a problem on the first run. It's a problem when you think that most of this software is designed to stay there a few years, now not many, but 3 to 5. Plus, everybody has in mind that Agile, continuous deployment. I mean, that's why we are doing that. Yeah, but then you have continuous deployment. You have to maintain all the CI/CD. You have an integrator like us that builds them, and then maybe you want also to change us or whatever, or you are forced to change. And that's actually not managed, not known everywhere, lost, completely lost in translation. Even on the same platform, I tell you, last week we had a problem on a customer. We are, it's a project. Also, the project in itself is interesting for software architecture. It's a project for managing notification between systems, between applications. All of our customers are building sort of notification centers. So you don't have the hubs anymore. They are not enough. They don't work. The world is to move too fast. But you don't have anything else to substitute them. So customers, what they do, they build kind of system. They take events from different systems, and they propagate these events to other systems or people. Can also be notification to people. I think I don't have in mind a single customer that's not done this or doing that or doing this. So we were building this system on, we were building the extension of the system for the Salesforce.com for a Salesforce.com platform of Intesa Sanpaolo. It's actually the customer, the largest bank in Italy. There was another stream of project delivering a completely different project. Salesforce.com, like most platforms, has some resources that are in common between the different streams. So if you deploy, there are some common resources that everybody touches. They do kind of tenancy model that is called org, but if you work on the same org, so different teams work on the same org, so on the same kind of tenant, then the deployment must go all together. You have to sync the deployment. Or you render the common resource completely inconsistent. So you can imagine what it means, having the idea that an agile, two-pizza team, and so on and so forth, must deploy fast and fast and fast, and so on. On the other side, you have a platform with a constraint in which every team should deploy together if they share a common resource that on some platform is always the case. And it's a completely unresolved topic. If you split the tenants, then it becomes an inconsistency of data, and so on and so forth. So microservices in terms of let's monitor them, and so on and so forth, not much. But how we cope with this agile development and the continuous deployment cycles in complex organization with hundreds or thousands of teams working on different platforms and with common resources, that's currently the mess all our customers are in. Wherever you are doing an on-banking system or you are doing a software-defined car and so on and so forth, this is a big organizational problem, and there are no tools, nothing that helps you, and not even methodologies. So currently everybody is trying to figure out how to manage it. There is not a single meeting which I don't get questions like, should we do a single tool chain? No, because you cannot do one CI/CD for all the companies, so that's not the answer. So how do we do it? There is really no answer today. Okay, changing completely, so we are on top of the cloud, we go below. What's happening in parallel is the cloud provider has become the largest telco operator in the world. So AWS has the largest telco network in the world. This is a slide that I took from a public presentation of Deutsche Telekom, actually. That was exactly pointing out this topic. Because they are connecting every single physical object. So at this moment we were talking about software application on the cloud. On the other side, you have the edge. So I don't tell you what is the edge, of course, but I put this slide to say it's an incredibly growing area. It's what today it means cloud platform at the edge. That is how most of the connected products are built. So we build them on the edge solution of the different cloud vendor or with some edge components of the cloud, simply because that simplifies a lot the interconnection with the backend. Of course, not all. In some cases, you want to rebuild everything. But if you see, the large majority is built in this way, with the idea of seeing a continuum between the edge and the backend. I don't think, well, my personal opinion is this is not an approach here to last, but this is what actually is on the ground today. And what happens on the edge is that the type of pervasivity, the pervasivity on the physical world is increasing year on year. So we started in 2009 working on IoT. Then from IoT platform, that was basically take some data from the field, you start to get into connected products, autonomous things, car, but not only, so you put intelligence on the products and more autonomy. Today we are going at a smaller scale, working at the sensor level. That's, of course, has all other range of problems, because you cannot do an over-the-air on a sensor, and so on and so forth, like you know very well. To make some example, this was a range of products. Well, over the year, there are some of the latest one. One of the first customers we got, this is on a connected product architecture, so not IoT, that is already 2014, and it is the classical, you connect your faucets, your hydraulic, you have the sensor to tell you if your house has been flooded, and so on and so forth. So, simple architecture, 2 layers, the edge, the connection part on the cloud, and then the data component on the back. I put some data to give you an idea of the complexity in terms of software, but quite pretty simple, I mean. As you see, you use a lot of the platform. You use a lot of the AWS platform to build that. So this project, the first family of the connected platform for Groe, I think the cost was like 800K, something like that. Small, but because you were using a lot of the AWS function. If we would have had to rebuild everything, it would have been much, much bigger. Of course, if you go on a different kinds of system, so like connected car, you have a completely different scenario. The architecture, you see a much higher view because the same level of Groe would be impossible to design in a slide. So the edge itself has several layers and it goes down to the electronic component inside the vehicle. You have de facto a very complex architecture on the vehicle itself, no more something that takes data and brings data because you have all the action, all the autonomy, and you have a complex architecture on the cloud in the back that probably connects a lot of cloud and a lot of data pipelines around. And of course, different devices that act on the product, with the product, with the cloud, and so on and so forth. When you talk about this type of architecture, you have few components, few software applications that, at least for me, came just with autonomous things. So a big advance in terms of, for example, vision. So everything that is vision software and software for automating vision, recognition, and so on and so forth. This type of field had a big development, especially in the enterprise, especially linked to the connected products and to putting the necessity of being able to put autonomy in the products itself. So this gave a lot of breadth to this.
It's not bad to sit down on. I know.
You had a very, you could talk to your instructor, the instructor.
Could you please mute?
Okay.
I don't know
My friends, can you please all mute? Or can we mute from here? Okay, well, I think they muted, but next time happens, we shut them up.
So on the edge, you have a lot of application. The most complex are making things autonomous, whatever function you can imagine. The cars, I don't know, BIMB, to make the BIMB more intelligence, the washing machine, all to make washing machine type of lavaggi, washing cycle, more intelligence, connected, and so on and so forth. Not just to automate the process in the back. And you have other applications. I put some that can also be the product itself or related with the ecosystem. So these are a few of the examples, but there are really tons. Now, the edge today is, the challenges that we face today are either for very complex architecture, the software-defined car. That's you know, a big topic. All the industry is working on it. And there the challenge is the complexity. I mean, the complexity of the life cycle, aligning physical life cycle to digital life cycle, bringing, you know, autonomy to level in the car, which require a certain level of safety. But that the problem is really complexity. In terms of IoT architecture, there are not. I mean, there are always challenges in the software, but it's simply a lot of execution. There are not big challenges. You get challenges when you get to the tiny things, or today you get another type of challenge. Do you know which is the most common workload today on the edge? No clue? Which is not so intuitive, because in reality you think artificial intelligence on the cloud, but actually today the most common workload on the edge is artificial intelligence, is to make things and systems autonomous. Because when you go on the physical space, I have not put an example on the traffic system. When you go on the physical space, actually, you cannot orchestrate things. There is not enough. You are not sure about the connections. The single systems, the physical system may be down, and the system must be resilient. There cannot be dependencies between physical systems, and so on and so forth. So actually, you have all these autonomous objects. In some cases, the intelligence is small. In some cases, the intelligence, like in an autonomous car, is very big. But these are all autonomous systems that then related to each other in kind of swarm architectures, sometimes orchestrated by the cloud, sometimes out-orchestrated between themselves, again with blockchain type of architectures. So, actually, to make all these things out there autonomous, you put some artificial intelligence. Because you have to have some intelligence for the objects to move, unless it's, you know, very, very simple and very, very binary. And this is one of the big challenges, actually, of the edge. How to run AI, which model. The model that run on the cloud and are taking a lot of popularity are not the model you can use on the cloud, on the edge, and so on and so forth. So it's every time you design a product, this is one of the big challenges you have. Artificial intelligence is also the third most common workload on the cloud today. Again, maybe not so intuitive. If you see the growth rate, my prediction is it will become the first in a very, very short time. I put a data by AWS. There are not so many public data, but if you go and do a visit with a cloud vendor, you have no doubt that is rapidly becoming the most common workload on cloud too. So we are using artificial intelligence in a lot of applications. I'm not saying on every application yet. I will say every application is on the cloud today. Every application is data-centered. If I don't have a precise number, but if I have to put my rule of thumb, today 30% of the application software system and so on that we are building have some degrees of artificial intelligence inside. And I think that if we have to look at the discussion, so the thing that will come in the next month, probably we are already like at 50% of the discussion with enterprise include artificial intelligence in some way. Which is a very big number. I remember, we started the first company on artificial intelligence, machine learning, because we called it machine learning. I think it was 6 years ago, something like that. So the first team dedicated just to that. Consider that we did on the cloud on 2008. If we were as good as, you can inference the maturity curve, assuming that we were able to spot in the same moment the phenomenon for the enterprise. So we are doing a lot of automation work. Not always with AI, sometimes it's just RPA, but most of it is, the discussion today are always with AI, and most of what's done there anyhow includes artificial intelligence. It became really very easy. I don't know if, do you know how many, because it's, for me, now this is an example of a couple of years ago, but it's always astounding how fast it is to do some work today. If I remember, when I started, for me it's incredible. Do you know how long does it take, how many lines of code does it take to write a code that recognizes plane number? Yeah, something like that. So, in reality, what you do is you use GCP, and you use a couple of lines, 2 or 3 lines of code. There's 32 lines of code, of which the real ones are a couple, because the rest is to print it, basically, to print the output of, to get the image and print the output. You use artificial intelligence, of course, to spark, so automation work is a big chunk. We are automating everything on back office, so I think you know all of this. The other big area is creativity, so we are starting to use at an alarmingly fast pace artificial intelligence for design in everything. And of course, with the large language models in the past year, I would say it has skyrocketed. This project in reality started almost 3 years ago with Marazzi, which is an Italian group that does tiles. They produce tiles. They design and produce tiles. So they started a few years ago to experiment, a couple of years ago, 2.5, to experiment in using artificial intelligence to design new patterns. In a more original way, in a more sophisticated way, and so on and so forth. Like to try to replicate, for example, type of marble that today you don't find anymore because the cave has been exhausted, or simply to get, again, new idea of patterns because they can do more and more personalized production depending on the people, the costume, the country, the moment, and so on and so forth. But you can find that in everything. Then there is, so automation work, spark creativity. Then there is, for my opinion, the biggest area of all, of application of artificial intelligence. Someone was laughing, so probably you know this chunk.
Developers.
So, this was Steve Ballmer. This is Microsoft. I don't remember what they called at the time, if TechEd or whatever. 2006, so not so far away, no? Now, this was this year Ignite in October. So it's Satya Nadella, and probably you know him, he's the founder of OpenAI. So Nadella in October gave almost, I would say, a quarter, if not more, of his keynote to OpenAI to present a new version of Copilot. How many of you have played with Copilot? Okay, a few. So the new version is pretty amazing. So it's not out there yet. What they some of you have seen this keynote. So basically, what they presented is a classical prompt: write me an algorithm to calculate the probability that a certain team win a contest, blah, 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 given certain parameters. What was crazy is that the machine starts and writes the test solutions. So writes the test cases and the solution to test itself. Then writes the algorithm, tests itself against the solutions, and then correct itself 3 times, and then finishes producing the algorithm. So this is an incredibly fast feed. So we can, of course, they make errors, but they are also coming out very, very fast. And we are talking about this year with next generation that already corrected themselves and are able to correct themselves. They are also coming out with speech to code. So now you have to write a prompt, then you could simply interact vocally. By the way, advances in speech are coming out fast on not just on coding. So most of our people have played with it. We had OpenAI Playground in preview a couple of years ago. So we started a couple of years ago working with that. The first tentative were a little bit rough, then it gets better and better. And it's clear that we will all working with that. It's clear that will heavily affect software architecture because, for example, what you learn is that you have to write small chunks of, you have to design the architecture in small chunks of code. Sorry, so I finish a concept. In small chunks of code because, of course, it cannot yet design a system split into architecture, so it can write a piece of code. But it means that probably we will go in even smaller microservices. Not bigger, because you make a design that can take advantage, either at function level or anyhow at independent services. We're not going to bigger things. It means also that you have to rethink all the software development lifecycle. So going back to our microservices thing, I don't think that's the problem out there anymore, because what's after Sec DevOps? So it has a lot of implication. I want to show one example that was published, I think, a month ago on our internal portal by one of our people, because apart from OpenAI, all the industry is embedding OpenAI model in its own product. And it's embedding it for doing automation work. So, for example, Salesforce last week at Trailblazer announced that Einstein now is basically ChatGPT. So Einstein is the AI engine of Salesforce. They just launched a version that embeds ChatGPT, like they built 8 services around ChatGPT in all the pieces of Salesforce, from the customer service to the development platform. That's, of course, mostly for the automation work. But whoever you talk to the industry is talking to OpenAI and is working to link their own products with this type of large language model. All of them. So in this year, all of the products out there, apart the competitors that are doing the same with their own technology, so Google is doing the same with its own technologies and so on, they are all coming out with large language models embedded in it. A new platform, a new startup, so there are hundreds of startups that are working to create a new application leveraging large language models. I show you an example that is of this work, for example, of code automation, not yet pre-integrated, so the integration is done by this guy that is René, with Unity. Do you know what Unity is? Unity is, a few faces, just Unity is one of the 2 biggest engines in the world for doing 3D modeling production, and they use it for producing games, movies, and so on and so forth. And they are especially specialized on real-time 3D.
Hi, and welcome to this quick demo video of using ChatGPT to actually write code for the Unity 3D engine. So let's get started. I'm going to ask it to write me an Unity script in C# that rotates an object around its center. All right, let's go. Let's see. Come on, ChatGPT. Here's an example.
It's not very visible.
All right, that looks good. Rotation speed, yep, that's good. So it has a public field here, which in Unity will actually show up in the editor, so you can control it from outside. Then it does the correct transformation around the up vector with the rotation speed of delta time. Looks good. Alrighty, so let's copy the class name and get over to Unity. And so let's create the C# script. Wow, what's going on today? All right, so we have the C# script here. Let's open it in Visual Studio. Give it a second. It just compiles it for a sec. In the meantime, we can actually already copy the whole code here. So let's copy the whole code over here and go back to VS. There we go. Reload the scene. So this is the default, basically, that Unity creates. Let's remove all of that stuff and paste in our code. Okay, got everything. Save it. Let's go back to Unity. There we go. It will compile it again. Just give it a second. Now we gotta add, of course, our 3D object. I'm just going to add a cube real quick here. You see the cube here. And then we're attaching our script. Just drag and drop on the cube. There we go. Press play. Let's see if it works. All right, it rotates. And we can even control this public field here, the variable basically. And look at this, it rotates faster. So that's pretty impressive, right? And again, we just told ChatGPT, write me a Unity C# script that rotates an object around the center, and it got perfect code. That's really, really impressive. Well, that's pretty much it for today. Thanks for watching. Might be back with another ChatGPT demo video soon.
Okay.
All right, take care, and don't abuse the AI. Bye-bye.
Okay, the video was not good, the machine it probably is too heavy for this machine. But basically, he asked the ChatGPT to write a code in C# that makes an object rotate in Unity. Cut and paste it into a Unity function, and that's done. It worked, no control, no change, and so on. Now, René did it by hand. So, ask GPT, passed it, and so it's a little bit cumbersome, but we were in Unity last week. They're coming out with GPT pre-integrated. So all these type of tools are coming out with the fact that you will tell simply what to do inside Unity, and it will happen what we've seen in a natural way. And we are talking months, not years. So that's really an incredible speed. As I said, we start to have vocal prompts out. You know that we will have images as prompt on the GPT-4 version. So GPT 3.5 that has just been released has already images as prompt. So there is already a conversion between, if you want, dell'I and GPT, not just for generation, but also for prompt. But what I saw is, for example, that you not just you take an image, it will interpret that image. So if you do a schema, for example, of a workflow, you draw it by hand, it will be able to interpret your workflow and translate it into code. That's the type of things it does. So an incredibly powerful thing. Think about all the work we do from design of a schematic down to the code. We already have something out there from Microsoft end of last year where you can actually draw a web interface. It's translated into a simple software architecture of pages, calls, and so on. And then you can eventually use GPT out there to complete even the function. So this is already available by Microsoft. But I think by the end of the year, we will see further automation even in that. So we are really closing the loop from actually design, literally design, to production. So it's clear that the software lifecycle will be completely different. And if you ask me, in a short time, we will not talk anymore about microservices because we will work at another level. And there will be a lot of automation behind our back. between microservices and so on that take care of all of this. That is my personal view. Everybody is working automatic software operation and so on and so forth. So we will not have the time to figure out something on the software development life cycle and the microservices, because AI will make this type of thinking obsolete, like our process modeling and the web somehow. We have already a lot of people coming out with tools for portals, because everybody is trying to get the productivity, and every one of us working on their own platform. Figma has just been bought by Adobe, and so some logo here. This is, of course, a big topic out there. This is the kind of Sequoia. So this is the biggest fund in the Silicon Valley. This is the timeline they give for artificial intelligence model. So as you see, they give a pretty interesting timeline and a pretty appalling. We were told which is last week, which is the consensus of the employees of OpenAI about when general AI will be available. Having said that general AI, my definition is you have an artificial intelligence machine that can design another and develop another artificial intelligence machine. When do you think is the consensus of OpenAI for having this type of possibility out there? The internal consensus is 2028. So they think that they will be able to give to the world general AI by that date. Which is, I was thinking more in the 2030, but Sequoia goes in the same direction. Now, I don't have time, so on this I will go very, very fast. Of course, this all combines with the immersive web and the advances in 3D. We spoke about Unity. I will not speak about the metaverse and all of that, but I want you to show an integration in terms of 3D and the backend. Show you a video of this has already almost a year.
Hello and welcome.
Ah no, sorry, I put the wrong video. No, so I will tell you. So we built I'm sorry, okay, let me see whether I can fast forward. Because I put you the video of a meeting that we did with customers.
You used the wrong prompt from the ChatGPT.
Yeah. Unluckily, it's not ChatGPT, it's me, so I make much more mistake.
In London. And today
Many
we're
more
here
mistakes.
At this exclusive event for
So
Rose
let me
members
see if I
to talk about the
can fast
metaverse,
forward and
meta-humans,
show you Rose and find something where we have Rose. Okay.
Answer, and you use text to motion to, for instance, you cannot have someone answer.
We are doing great, thank you, Rose.
Okay.
Experts in the field of digital humans and the metaverse today.
René?
Hi and welcome. I'm René Schulte. I'm also an AI and metaverse expert and also head of 3D.
They present
I feel
themselves.
very good, thank you. How about you?
We are doing great, thank you, Rose. And today we're going to be looking into how
A representation of us, and they can replace real humans in situations where
like be a moment.
Real, presence is not needed, or maybe it's not feasible. Like for instance, you cannot have someone answering on a web page any customer who has a problem. Now, there are different types of digital humans, and that depends on what type of interaction you want to have with them. So, for instance, you can be a real person with a digital face, and that's a digital human. However, that is possible using face tracking and body tracking technology. So there is actually a human behind. Or you can be the so-called AI-driven digital human. That is a digital human that is powered and moved, like animated by AI technologies. For instance, you can have speech recognition to understand what the user says. You can have conversational intelligence, NLP, on the back end to understand the question and generate an answer. and you use text to motion to give the answer back to the user. So these are basically the two types of digital humans that we have.
So when we're speaking to a digital human, like Rose today, we aren't necessarily getting responses that have been human-driven and pre-programmed.
Okay, I wanted to show you, Rose, but it goes too, it's too long. So basically, if I'm not able to, it's too long, I leave you here if someone wants. But if you see Rose, it's basically built in this way. You have a 3D model. In the case of Rose, it's a system called Trudians, so it's a software as a service system. There are several out there. You will be able to use Unity by the end of the year because they are integrating the real-time model and opening up with APIs. But anyhow, this gives you the 3D. Trudians, as you saw by the picture of Rose, is already quite good. It's not the best out there. There are some that are more sophisticated. On the back of that, we integrated GPT-3. This was done 1 year ago. I mean, the event is most recent, but the project is almost a year old. So it has a GPT-3 in the back. So you can talk to the digital human and you get answered by the artificial intelligence. And then you have a text-to-speech for the answer. And on top of GPT-3, in this case, we put a dialog flow by Google. So to be able eventually to redirect some questions to more specific answer, because today ChatGPT, GPT-3, it's the same, doesn't allow you really to be more accurate in terms of, for example, if you want to, if they ask you a price for the next car and you're talking about a configurator, you want the entity to give a precise answer. You don't want to have the freedom of GPT to figure out the answer, you know? And in this moment, there are some technical limitations to do this type of application. I don't think we will need much for long, this type of double architecture. Probably in a few months, we will be able to do it with more sophisticated API provided by Microsoft or OpenAI or Google and so on. But in this moment, this is kind of a way. So you have a 3D modeling, avatar modeling, you have dialog flow, and you have a GPT-3 on the back. And that's an autonomous system that you have to integrate and make it, because this is an example in which you talk to them, but you can have the face or not, but it can also be an autonomous system that, of course, will talk to other autonomous systems in a flow of data. Industry, this is not just, industry is moving really fast on that. These are examples of projects that we have been doing. Also because that's the natural evolution of chatbots and also all the industry is trying to do. With this, I stop because I'm out and I leave you with this question because I have no clue what will become of software architecture when you will have all these autonomous systems talking to each other. And integration is a completely different thing in that moment, in my opinion. Thank you.
So thank you for the inspiring talk about what industry is doing. So the floor is open for questions. Who wants to? I have plenty. So, but who wants to start? Who dares to start? One.
I think I can pick, even without a microphone, if it's fine. Basically, in one of the challenges, you talked about how the app of the future will be either with composable apps, with composable architectures and structures, or blockchain-related, or SaaS. I know that Reply for sure has to do some R&D around these directions. I wanted to ask if you bet on one specifically, or equally on all four.
Okay. As you see from, if you take that picture and this last piece about the artificial intelligence, what I bet is the decentralized application schema. so the blockchain type of team, and this is what we're betting on, with intelligence entities and pipelines of data. So a kind of fluid world of pipelines, intelligent entities, and decentralized way to coordinate all these entities, because I don't believe that the exploding complexity can be managed in linear ways. But the word is muddy, is not. So in the meantime, we have an enterprise world with a lot of legacy. So enterprises will have composable apps, will have the big suite like Salesforce and others in which they will consolidate under big vendor and big suite, while they develop the new products with more daring type of architectures. So if you reply as a network company, so we are done 150 companies, 150 independent teams. Some of them works on the classical applications approach, because if you're working with an area of an enterprise in which you have that type of architecture, you have to be able to have them there. Other work on that. If you ask me, where I think that the really, when you work on greenfield and the really new things that you can build, it's on the apps.
We got a question from the online. I don't know if the speaker wants to unmute or.
No, just.
I can read it.
Yes.
How do we think this will evolve? Will requirements engineering be the only one who will have jobs in the future?
That's you know, there is Kurt Weil. Everybody I mean, who thinks herself or himself a serious architect? When Kurt Weil did the Singularity University talking about 2045, and I consider myself one of these, you were like, you know, that's a lot of bullshit. But in reality, I have no clue what it will become. So we are trying to understand. Today, when you do a project with artificial intelligence, I mean, the models are out there. So either you are making the new models, and this is your work as academy. And I hope that we are not dying with LLM. So I hope that other models will come out, maybe with less, consuming less resources, more sustainable models, to come to Patricia's area of study. So this is a big area for the next years, of course. For the industry, if you look at these projects, so when you work with AI, the project is very little software integration. So you need one good person, probably, no, I'm joking, but very little compared to today. You have a lot around the data, more than requirements, because an artificial intelligence project is about first and foremost data, what you have, or you can also generate data, so synthetic data and so on. You can take out data from people with interview, registering this meeting, Teams, whatever. So there are tons of ways that can also be automated. But it's about data, and it's about visualization, speech, and so on. So requirement also, it's a word that is very dangerous. So honestly, so I have no clue. I don't think we will be out of work. I think that IT is done by few really experts. So few people that have really the training. You work in the academy, you know the data and how many people come out of academy every year that are really trained on informatics, not many. So you see how much demand there is for the highly skilled people. And then there is a long queue of people that in reality do manual tasks. And they have lower backgrounds and so on and so forth. In the digital experience area with the graphics, one thing is, a certain type of creativity and also operation. One thing is basic, below-the-line graphics. The same for informatics. Think about all the tons of people managing subsystems around the world. So all these, in my opinion, will disappear. I think that the high value, job, no. What it will be, honestly, I have no clue. I think it's the biggest question of all.
Hey, hi. Thank you for this interesting keynote. It's also a little bit scary towards the end. So the question I have is, often we see that, AI development on one side is very exploratory. You start with data, then you come up with a model, and you again go back. So that's a different kind of process by itself. On the other side, we have this agile process where you have this, continuous architecture that is emerging out. So how, in reply or in your experience, have you seen this conflicting development practice, and how have you solved it? And also, what is the role of architect there?
But in this moment, the architects luckily have to deal, and for at least 20 years, they will have to deal with a brown field and not a green field. So you keep needing architects. You may be working on a pure AI project. In this case, honestly, you don't need much of architecture, but it's for that specific component. So that's a component of a bigger picture. So when you will not have one model encompassing all. That's you have platforms on which you develop your own your own training. Because, for example, the example you were making today, you train your own thing on top of an existing pre-trained model. You fork it and you have your own intelligent agent. Tomorrow, probably, this will be on top of a platform with kind of tenancy logics and so on and so forth. And probably you will have them on several platforms. Because, as I said, all the industry is moving. You will have them on Salesforce, you will have them on your own custom running on virtual, on OpenAI or Microsoft environments, and so on and so forth. So architects, I don't think they will not have work. I don't think that the problem they will face are the same that we face today. When the industry will mature with the data pipelines type of approach and how the system auto-regulate a bit more themselves. I mean, the industry will come up with other models. Today models are classic. We just have classical approaches. You can just integrate, make data flows and so on. You still don't have a lot of tools. But you start seeing data pipelines mature and mature, data mesh type of approach mature and mature. This means that you're moving the architecture up one level. So software auto-provision itself. You don't have to worry too much about the physical architecture unless you are one of the ones building the physical architecture. Or unless you're at the edge, because different speed with the physical world when you have things and not just bits. So there will be work there, but maybe not in the large enterprises. The large enterprises, the architects will be up one level. Data architecture, are also autonomy and intelligence architecture. What is the level of entities, the granularity? You have tons of things to do. It's just changes.
Hi, Riccardo Scandariato from TU Hamburg, and thank you for the talk. I had a question about whether you are changing or preparing your quality assurance processes for the era of generative programming that is coming. So you seem to be very interested in this ChatGPT and replacing the developers. I understand that. I mean, from a cost perspective, it's great. You know, there are a lot of studies, like they published the paper which was called Asleep at the Keyboard, where they tested the security of the code generated by the first gen of Copilot. Now we are coming out with new studies about how vulnerabilities are introduced in ChatGPT and Copilot v2 and so on and so forth. I wonder whether, so in the end, the goal is to get as good as the developer, and we know how they suck in terms of introducing vulnerabilities.
It's GitHub. I mean, Copilot learned from GitHub, not from else.
So I wonder whether that is the goal or whether that concerns you, or if you're preparing internally from an organization perspective on how do we manage quality assurance for this new development pipeline based on generative programming.
Okay. For me, it's not a concern. It's really a lot of opportunity coming out there, and every time that there is this continuity, there is opportunity along all the value chain. So, We started to build the first team 2 years ago when we put the hands on the first version of Copilot, that you could see was even rougher than today, okay? But exactly like with AWS, EC2, S3, you see the potential, you see that it will work, no doubt on it. All those topics to solve, like with the cloud, but it will be mainstream. So we started the first team inside the network that their mission was just to do no code. So they cannot take work, if not by automating a large chunk of it using no code platforms. So, and this is a way to force all the, this is, for example, one way to force all the others also to move, because, as you say, they disrupt, coming with a different approach to things, and they are evolving every month how with the technology. They disrupt with pricing, but you know, in reality, what I learned in my life is that enterprise are not really moved by price. Everybody has always this obsession of price, but they really don't care much, because the cost of something is just relevant compared to the value of that thing. You mean, I don't know if in English it comes out well, but the point is no code is interesting because it increases quality and speed, not because it reduces costs. It also has the potential of reducing costs, but at the beginning you will increase costs because you will put new things in parallel to the old ones. You will have to learn how to cope these new things. You have to change your skills. So it's always a painful process also for enterprises. But the promise is quality and speed. And then, of course, you have all these challenges. What do you test? It's not that tests disappear. And how you test? When you have this type of system, one thing that we are working on now is exactly how do we test it with the customers. You do 500 questions, and that's the best test you can do. It's not deterministic. So are all open questions, but it means that there are all new field for new ventures, new companies, disruptors, and for me it's good for the economy, whatever there. So, before we close, because I'm the moderator, then I pose the last question. And, then just answer with one keyword. So, we got a new funding from the Dutch government to carry out software experiment in industry. So we move our software experimentation lab in companies. So what would be the one thing that we have to do with them? AI, if you can if you have to choose within AI, you want to be actual or forward? Actual is AI and generative AI. So generative adaptation of software? No, try to do new products and service with generative AI, how you leverage it. And the big question is, when you do fine-tuning, what you can transform into an asset, and when you just use it. Okay. Fine-tuning is expensive, using it is easy, but for the industry, the point is, when do I spend to use fine-tuning on this model? For doing what, because it means to innovate what, but really innovate, not just cut some cost on a process. That will come with IT. Thank you. Let's thank the speaker. So, Tatiana will be around until after lunch-ish, so you will have more opportunities to chat with her. And now is coffee break.
So welcome. Can you hear me? Yes, works. So welcome to this session. So this is a working session. Will be about automotive and how we organize that. So first of all, I'm Patrizio Pelliccione. I'm from Gran Sasso Science Institute, and we have OI. That she will give a talk in a while, and she will set up the entire scene about automotive, and she comes from Volvo Cars in Sweden. So I'm chairing this session. I'm home 2 times because I'm in L'Aquila. Gran Sasso Science Institute is here, but also I was working before at Chalmers in Sweden, and I had a strong collaboration with Volvo Cars. So for me, it's really a pleasure to be chairing this session. So it's organized in this way, but a working session means it's not only us, you should have an active role, but in order to stimulate discussion, we organized in this way. I don't know how much you can read, but the first one is a bit longer presentation because it's from industry, and then she will say the evolution of architecture over time, and she will talk about what they are doing at the moment, challenges, and what is important to work in the topic. But then there will be also David Garland that he acknowledged to be part of that, and he will highlight a bit of human aspect in this topic. He's working on that for a long time, and in general on autonomous systems, but indeed also for vehicles. And then there will be also Ian Gorton, that is there in the back. That is also another well-known person in the ICSA community. And even though he's not exactly working on that every day, but he will talk about and will highlight topics of continuous development, agile architecting, technical depth, and how these connect to the software developing vehicles. And if we have time, I put this also on continuous compliance. That is something in which we are working at the moment, and I think it's a very interesting topic. But let's see where we go. So in order to stimulate participation, indeed, you can ask questions whenever you want. And also why I was saying before that she gets bored when people don't ask questions. So don't be shy. At any moment, if you want to ask questions, just ask questions. But by the way, I created a working document. It's very minimally structured, but feel free to change whatever you want and participate and write questions, and we will see what to do with this document at the end. But I think it's always good to have a table on which to write what you want. It's working, right? Good. So you have done. I see some phones still. Yeah. Works, right? Good. Then it's my pleasure to introduce the first speaker, and she will tell you what they are doing in Volvo Cars.
Hello, everyone. Okay. First, I have to warn you that it's my first time at this conference, and I am kind of outside from software engineering community. I'm called myself, come from this computer engineering, where I work with low-level software like a real-time kernel, real-time system. I am familiar with automotive stuff. So my name is Hoài Hoàng Bánh Son. I started at Volvo Car in 2018 as a system architect for the complete vehicle, meaning that we had to work with own unit or own department in who own the function in the vehicle and how to make them work together. That's our role. I am leading the in-vehicle communication Ethernet expert. So thank you, Antonio, if you are online, for invited, and thank you, Patricio, very much for inviting me for this nice conference. And I hope that we could have some interaction because I'm new, so I would want to learn from you as well. So ask if I present something that feels strange to you. So, automotive software in terms of number lines of code. So this data come a little bit old from 2018 when I started at Volvo Cars. 100,000 lines of code. What does it mean? You compare with other industry. Here you have Space Shuttle, you have Boeing 787, F-35 Lightning II, and you see that, okay, it's a real software system. But does it make the car become a software-defined vehicle? It's complex. We have been using software in the car for many years, 20 years, but the term of software-defined vehicle just come recently, become very hot topic. Isn't it because of many software? Let's take a look. What does it mean from OEM perspective, from Volvo perspective? What does it mean when we say that we produce a software-defined car? So first of all, software defines the user experience. When you drive the car, you feel different experience. It's because of the software, how the software developed. So it's the main, software is the main competitive differentiator. So all OEM together, working together, we use the same standard, we use the same hardware, but what makes us better than the other is the software. So software is the focal point for automotive innovation. You want to send new service, you want to send new application, so that is the way how can we make money. Yes, and software is the main asset for the OEM. So what becomes important when we change the way of making the car? Car and cloud integration. You had a very good keynote speaker this morning, very clear. How can we put the software in the cloud? What kind of application? How can we do the car cloud integration? And at Volvo, we have our own Volvo Cloud, and we have a Volvo IT to work with this. Continuous evaluation after the sale. You buy a car and that's it. You cannot change the car hardware, but you can change in the software continuously. So it had to be changed the way of working. Control over the main software asset. And sustainable high development speed. So you don't want to lose in the competition with other OEM, right? So the development time is the key. How do you make sure the quality of the software and develop it? So what will be effective then? How we make money? The business model. Driver don't own the car. We, Volvo, own the car. So we do the Volvo on call. You use the car as abonnement. It's like a mobile phone. You subscriber. You use the service. How we structure the hardware and software? Of course, if the hardware and software doesn't change, we cannot have to change to be able to enable this thing. And how we work the process. And of course, sometimes we make a joke. Looking at how the company organized, you can guess what the architecture look like. Or you can guess what topology look like. So that's how we change the way of working process, and we also change in the organization. And we want to develop our own software. So we have an in-house different team to do this. So today, my talk will focus on how the structure, the hardware, and the software to be enabled this kind of thing. Okay, because the talk is about the evolution of the electrical architecture, so I would like to start where we are now and how did we get there. So it started in 1927 with very simple car. It's a poor mechanical car. So can enjoy models. Very simple. You see very few mechanical and battery, thin light, headlight, some horn. So that's where we start. But here, now we look at this scary picture. How it grows from the few handful of electronic device, or for handful of the ECU, or we call it ECU stands for electronic control unit. You see how it increased. So in 2020, we now develop a huge platform, centralized platform called SPA2. SPA stands for the Scalable Platform Architecture. The one you see in XC90 is SPA, and now we do a SPA2. And you see the number of ECU, we have 150 ECU. They're doing different functions with a lot of dependency. How can we make them work together in fast development? So then the whole industry talking about now, if it won't work, if we continue increase like this, it's limited in the hardware, limited in the power, limited in the cable and everything. It won't work. So we're working together. We make a new architecture that allows us to reduce number of ECU. Here you see another picture, which is megabyte, how much software. It is more scary. Okay, in the XC90, you see like about 900 megabytes of data be downloadable to the car over the software download. But here in SPA2, we haven't got the car yet, but according to some test data, you will see say that we have 15,000 megabytes of download data. And then it predicts that in the new platform that we are going to release 25, 27, it's going to be 150,000. So it's meaning that it increased very, very fast. How can we solve this? How can we handle this? This thing even something is that, okay, you look, 150 ECU connect to each other, talking to each other. You can real mess. Okay, everyone can talk to each other, real mess. And 70% of the resource are using for this communication on the bus. So what we have to do is that to reduce this one first. So I'm going to tell you how we do this. Now, always the number of how many kilo cable in the car. Can you guess? When I first started Volvo, people asked me, I have no idea. Now see, you see number here, 45 kilograms of cable. So we have to reduce this. The whole industry working together to reduce this. BMW, Volvo, Volkswagen, everyone. So we are together on board. Okay, so now you see on the challenge, you see the picture, you see, okay, is it possible to make software-defined vehicle after all of this? Any questions? Yes?
A quick question. So when you said network signals or something on the bus, do you mean, like, for instance, CAN messages or communication protocols?
Yes, CAN, LIN, flex race, Ethernet, but very few Ethernet. Okay, where do we go from here? So we do different steps. So we are one of the, very proud to be a Volvo, so to say. We are the first one, very brave company in the whole world to start with centralized architecture, putting everything together, okay? So that's what we did first, centralize. So we do the separation of policy and mechanism by making high-level decision, vehicle decision-making in the center part, and low-level control in the ECU. That's what we do. So we look at the horizontal slicing instead of the vertical. So that's the first step we do, centralize. And then to be able to even reduce number of ECU, reduce number of functions with integration, things that can do together, we put them together. Okay, so we put number of ECU together. I think Volkswagen wants to present at automotive conference that they want to have a car with like 5 different ECU instead of 150. So that we do integration. So that's 2 steps, they're not the same thing. So now is, yes?
Very quick question. So when you say zone, do you mean, sorry. Thank you. So when you say zone, is it similar to domains or is it different from domains in the car?
Different in the domain, I will explain that.
Okay, thank you.
So this is how we do centralize. So we bring the vehicle in the mindset that, okay, we bring the brain of the vehicle, which have our own control key function. And then we have an infotainment system, which connect to the cloud, which audio, video, streaming, user interface, all of them are together. And we have a self-driving system, which are AD, ADAS, on the autonomous driving module, separate. And they are connected via Ethernet, of course. So with Ethernet, we can enable a lot of things. I'm biased here because I'm expert on the Ethernet. Here's how it looks. So in the middle, in the middle, here's a we call the vehicle computation unit, which is a very high performance processor system on a chip. We have 8-core system. Inside that we have a number of sub, not just one. We separate this high performance and high integrity function. So we do physical separation. DHU is infotainment SOC, which is high performance as well. You have a different, I will later on introduce you what kind of software platform do we use. And then we have autonomous driving module. So that on the blue here you see is a gigabit Ethernet. So that enables to send a large amount of data between them. And then we have those black box that are ECU who do like here we have a brake. Here in the front here you have brake, you have a steering, and then you have audio, you have a different thing here in the connect to the infotainment. And we have a VIU, which stands for Vehicle Integration Unit. So we makes it scan information. Here, red is the CAN bus, become the Ethernet, and go into the vehicle central part. And why Ethernet? I will explain later why it had to be Ethernet. Not just only because it can carry up to 10 gigabit of data, fast speed, low latency, but also enabling the service-oriented architecture. So have a communication protocol that only run on top of the TCP, UDP to be able to call the function as a service. So an ECU in the mechatronic ring is highly specialized for the controlling specific device. So we have like a brake, steering, door, window, etc. So we have a VCU is doing the high-level coordinated fundamental capability of the mechatronic ring to the vehicle. So for example, vehicle dynamic, climate control, exterior lighting, and so on. Yes, and then we have a VIU, I already explained it. In this case, it's a gateway. So that's no domain architecture. Okay, no domain. Domain is that you have a different group of ECU that do a similar function. Then you have a one domain gateway. Now we don't have that. In zone and architecture, zone is a geographical location, not domain. Domain, you can have a lot of cables. Now, so that is for step one, we do centralize. And now we go to step two, which we are right now. So what we know is that we move, for example, we reduce cable by further integrate similar function. So instead of one box with alternate driving, we put them together with the VCU to become one part. Okay, so we own the infotainment, we become one box, big box. And then, for example, now we have a zone controller here. So what are the different? Zone controller is the geographical location in the vehicle, left and right and tail and so on. On the ECU that is closer to zone controller will connect to the zone controller. So it will do the power, provide the power to the different ECU. It wake up, it also do some function, some control function. So in this way, it will reduce number of cable. So BMW have done a measurement how much cable they can reduce. 36 kilo of cable by moving from domain architecture to zone architecture.
Can I have a question?
Yes.
Why you are working with other companies for reducing the cables? Why there is the need of inter-companies effort? Why Volvo Cars cannot work alone on that?
No, we're not working alone. So the whole industry going towards this direction.
But you work together, or?
We have, for example, yes, we have an open alliance who we do have an alliance who work together. So we push suppliers to use different material following the standard.
Okay, it's for the suppliers, then you work together. Okay.
Yes. The only software that we work differently. That's competitive. That when we do a software, then it's different between different OEM. So here's how it look in the zone and architecture. It looks very clean, right? It's very, there are different ways. This is the way of moving forward. Everyone talking about zone and architecture. So different, some OEM have a 4 zone, some have a 6 zone. When some move from domain architect to zone and architect, so we are kind of hybrid. So to say, Volvo, we have a completely new zone and architecture. I already mentioned that. Okay, now maybe this is something interesting for you. Or does it mean from the software perspective? So let's have a look at how we organize the software. How much time do we have? I do it quick. Okay, this is something maybe interesting. So here is a Volvo onboard software platform. I will walk you through. So here we have a core system platform who do the VCU, vehicle computation unit. Inside this, we have AutoSAR, of course, and then we have some QNX who do high performance applications running the POSIX software. And we have also Linux, for example, the part that connect to the cloud, and also have a Linux here. So you see most of the ECU are using AutoSAR. We only have a classic AutoSAR. So see the dominant part is the AutoSAR, and then the high-performance bus, we use POSIX, QNX. And then we have Linux when you go to Google, cloud, and so on, telematic application, then we have Linux. So that is how the Volvo onboard software platform look like. Now I'd like to have a little deep dive, maybe it's too detailed for you in this, but just ask question if you think that is too detailed. So here, if you are the one who know automotive, so you have a CAN bus, you have a link, and you have an Ethernet. That is three main communication mechanisms we have in the vehicle. So to be able to decouple software and hardware, right? So in the old way of working, in the old two ECU talking to each other, they just have a connection, a CAN bus to each other. Then it becomes very mess. So now we decouple, meaning that they are not allowed to talk to each other, but they go via the VCU instead. So to be able to do that, we group ECU, one ECU or group of ECU, for example, the one who connects to the door, they call them a device. Okay? So each device will have a two different interfaces. One interface of functional, and another interface for software download, for diagnostic, for different housing management function. So then each device will have some kind of API in the VCU who can represent some parameters, represent each ECU. Now, next. Here is how it looks in the software structure. You can see here. So each device will have a device proxy. So the communication, now I'm going to walk you through this. So as a device value, for example, we have a wind speed sensor, we have a different sensor, we have a climate sensor who collect data. It's a value, is some value from sensor. We make it a device later, is a data frame, pack in the frame, sending the communication. I will make it short. So we have a device frame. If you talk about Ethernet or you talk about CAN, you can have a CAN frame and so on. And then you pack it in the UDP packet and send on the Ethernet. And what happens then is that inside here, this device proxy represents one device. And when frame come to device proxy, device proxy will extract frames, become a signal. Then the signal will be translated into the service and call the function. So that is how we call it service-oriented architecture. You don't use the signal inside the VCU, but service. So function will have a different API, so you can use RPC, you call the function, you can use polling to call the function, even public subscriber or send to receive, send and receive. So that's how we don't use the signal. So by this way, you don't care where the ECU is, but you have a device proxy that can tell you, okay, where is it and which kind of signal do I need? It's on the way it looks like this. I'm not going on it, but on the way is how they change from signal to the whole up to the application, how application use the signal. Any question here? Yes. Maybe you can keep the microphone.
Thank you. I think it's a very, very nice abstraction that you provide among signals. But my question is, what happens at the back end? Because if you have a CAN message or CAN frame that has some timing requirements and it is supposed to go via Ethernet, and Ethernet can carry probably 80, 90 CAN frames at a time. So how does the timing affect, how is the timing affected? Because some CAN frames can be very urgent, or some may not be urgent. So how is this mapping done from CAN frame to Ethernet frame? Yes.
Yes, so that's the next challenge that we see. I come to that. This slide is better. Okay, so to be able to do this, so we call this software layering architecture. So we have 3 different layers in the software architecture inside the VCU or inside the vehicle, right? So we have an integration layer where we implement all of this device proxy. We also implement something called library where it puts signal to service. That comes to your question, how can you pack the CAN frame to Ethernet frame? So first we have something called the routing tables, and then we don't have a timing here. Something we put, in the old one you can put a timing requirement in some tool like a car weaver or some kind of design tool, but now we don't do it. What we do is that we do a scheduling. Okay, so we do the function point of view. So I'm working with different teams, for example, brake steering, they will have very tight timing requirement, but then I had to schedule their application first. And then we have some integration interface. HAN will stand for hardware application layer, where you make the signal become service. So now one example. So let's say you have one application. So this application, we need different kind of signal from different ECU to produce one service, right? So that is challenge. How do we pack it efficiently? You can do with transformation in the AutoSAR adaptive, but we have AutoSAR classics. So what we do is that we haven't found a way that, okay, how can we pack this one efficiently? It can create a very huge problem with the performance if you don't pack this in a correct way. So this is enabling something called also another hot topic in the automotive world, which we call service-oriented architecture. That's difficult, but the most difficult is changing mindset of people, carrying the signal-based ECU into a service-oriented architecture. That's a very, very much job. That's my daily job. So what we try to do in the company, we said that Volvo want to be a software-driven company. This means that we have to educate people how to well define the software design in the correct way, correct mindset. Service-based software, not a signal-based. And dependency is a very complex problem. You can pack, how can you know that the dependency between the signal when you pack them into frame? So it's difficult, very difficult to handle this. Separation of concern, you have a safety and you have a QM. How do you separate them? And then we use a modular way of design the software, so how to handle and govern the different kind of interfaces for software module. So they have a whole team do it. We usually think we have a team called the MIT, Modern Interface Team. Okay, so now I've been walked through how the software look like, how we design the software. I hope that it's clear to you. Any question, Patricio? I'm talking too fast, yes?
Could you say something about the quality attributes that you might care about? Safety, yes. Reliability, security. Yes. How do you build those into this?
Yes. For safety, for example, inside the VCU we have a high integrity processor and we have a high performance processor. So all A and D we put in one processor. But also when you have end-to-end protection, you have to handle it in the application layer. That's the one thing with safety, or especially when you go to autonomous driving, so we have a fail-safe operation. So we have extra CAN bus, so we have a diversity, different kind of one CAN and one Ethernet carrying the same information. So that's availability. Okay, for security, we have a security gateway. Everything comes from outside world. We go through the security gateway. So we do different rules. So we apply multi-layer security approach, meaning that all the guy, like Bjorn presented in the morning, the application do their own security mechanism. When it comes to the vehicle, we have a firewall, and when we come to network, we have an IPsec. We have a low-layer security as well. So it's multi-layer security approach. Yes.
Yeah. I was wondering why you are using AutoSAR Classic and not AutoSAR Adaptive when it comes to service-oriented architecture, because then you get a lot of for free. And the second point was concerning Ethernet. Are you using Ethernet like when we're using standard computers, or do you have like AVB or TSN, or maybe you can also comment on the use of some IP for service-oriented communication in DDS. Thank you.
You go to the point that, yes. So first of all, why we don't use AutoSAR adaptive? I had to answer this question many, many times. Because when we decide this, AutoSAR adaptive is not mature enough, 2018. And also, Volvo at that time want to be the software-driven company. We do a lot of development, in-house development. So therefore, we develop our own layering structure and something we call service framework so that we do our own. So that's why we haven't go to adaptive yet. So yes, we are looking at the maybe future. Yes. This only reason it's not mature enough at that time. So people want to be very, automotive ones are very, very conservative. We all use things that well done, well proven in the market. So that's all. Ethernet, yes, we use some IP. So we use some IP inside vehicle, for example. Here, when you call this function, when you have an in IPC between the functions, then it is some IP. So we do have an infotainment, we use some IP as well. So we use some IP with for the audio, video. We use the automotive Ethernet. We use the time-sensitive network, if you are interested. But so far, we only use credit-based shaper to avoid the bursting traffic and to guarantee some kind of bandwidth stream reservation for audio. So that we do have. DDS, yes, we are investigate and compare some IP and DDS, especially for infotainment and for the cloud communication. So the all are included in the work. So now I think that you have quite a good picture of what is a software-defined vehicle, what is the key. That we OEM have achieved to be able to produce software-defined vehicle. So let's look back then. This is a very basic picture. I just recently read it. So nowadays you buy the car, or yesterday when you buy the car, when hardware and software are coupled, and that's it. You use the car until you get bored and you want to sell it. Nothing happened. But nowadays when you buy the car, when we do the start production here, the hardware unchanged. The car is the car, unchanged. But based on your demand, we can install a lot of software package. So we even say we have the same infrastructure for autonomous driving car. So if you want to have autonomous driving, we sell you that software package. Okay, so continuous development and deployment of the software. So the main difference with software-enabled system and software-defined vehicle is that software can continuously optimize within the limited set of hardware. So that's the key. And to be able to do this, we need to decouple hardware and software. We need to do the service-oriented architecture. And last but not least, something here. It doesn't work anymore. I have some picture about how to download via over-the-air software upgrade. What is the attribute for this thing? So. And no, I haven't included safety and security on this topic. Yeah, so you can do this. So I have only 2 slides left. Yeah. So it's a very, OTA, over-the-air update is a very, very important part of the organization. The big team, whenever we have an OTA success, we need to celebrate we have an OTA success because that allows you to add new feature, upgrade security patches, and also quality update, so adoption of the later version of the operating system. When in the production, we can change in the hardware, but very limited, and usually we don't do it when the customer already buy the car. Yeah, so this is some key takeaway from this is that system design support upgradability, modular design with a stable interface, and software-hardware decoupled. So that's a few keywords that you can take away from this. Yes, here's a flow. Daco make this flow picture. That's how we do in the whole chain. And my part is only inside the vehicle part. Okay, thank you very much.
Questions from the audience?
Just a couple of questions. First of all, thank you for a fantastic presentation, I must say. You mentioned that you use AVB and CBS. Is it being used in the product or it's in the prototypical stage?
In product.
In product. Okay. Well, okay.
For the audio.
All right.
So
yes.
I did a talk. I will give a number of talks. We are first one who did this.
And do you plan to look at other features of TSN as well? Okay, that's
so
interesting.
I've done a lot of work. If you are interested, I did a lot of book about which features are suitable for a vehicle.
Okay, great. And last question. On the previous slide, you showed there's some communication of the car between car and cloud. So what kind of wireless communication is that? Is it 5G or?
It's 5G.
5G. Okay. Thank you.
Other questions?
It is so new to this.
I can have some actually. So my first question, if you can say what are the 3 most important challenges from the point of view of software, if you can name.
The name is decoupling hardware software. From software is a service.
But this is something that is already there from AUTOSAR, no? From many years ago.
No, AUTOSAR is a signal base. You have some IP, but it's still AUTOSAR. You have a HTML file, you send the signal, and software component read the signal from the RTE. But you can use service, but you need to translate. Adaptive, yes, they can do this in adaptive. So I think it's take away from software perspective is service mindset when you design the software component, model interface. So keep how to bring it efficient way and decouple the hardware and software.
And another question is also where you deploy when you want to do an upgrade. Which part you cannot touch and which part is instead updated, and how this relates to safety?
Yes. So this, I said before, inside the vehicle computation unit, you have a high integrity processor. There you have a.
Can you back to the figure?
No, this is the.
It's working.
So yes. This is a model interface. How do we decide the model? We have different product models. Some have a S&D, some have a QM, then we separate them physically. Here inside the VCU, I don't have that picture, but you have a high performance and high integrity. Where in the high integrity, you have a safety, all the safety. So preferable you don't touch that part. So every configuration are very static. So therefore, I ask beyond this question in the morning, that I don't want to change the network configuration at all. So all you do when you do the over-the-air update, you do it when you call the vehicle to the workshop. For the safety-related function, usually don't. You have to do it, test it in the workshop before you send it to the customer.
But what's happened if you need to update something and it's touching the certification and if it's touching the compliance with standards? What's happened? What do you do?
Yeah, you have to do it, but not when. So for the autonomous driving is maybe it's not related to your application, but I also want to say that for autonomous driving we have always availability. So meaning that we always send in the redundancy, and we have 2 different functions, and one is. But for what your question, I think we have to do it in test the car first, if it's comply with all the regulation and stuff before we send it to the customer.
Thank you so much for the talk. I have a question that is slightly related to what Patrizio was mentioning before. So when you talk about software and hardware decoupling, right? So which kind of software are you trying to decouple? Because I suppose that, for instance, if you have these by-wire functionalities, whatever, you don't on that kind of software you cannot really decouple much because of certification and so on. This is the first question, and follow-up is, can you perhaps give a precise, let's say, challenge that maybe at Volvo you are facing when you are trying to decouple software and hardware? Because I know that maybe this, let's say, problem of decoupling software and hardware has been, tackled in other contests and been solved. So I suppose there is something specific that, Yes. Thank you so much.
Yes, I think take this picture. So now, when we do the zonal architecture, we move on the control function to the zone controller, and the reason is that if this part broken, we still have a two zone controller which have the same function that make the vehicles go to safe stop, right? So that part, since it is in D, both of zone controller, that part we don't touch. And the key problem when we do decouple software and hardware is that. For example, timing requirement when it's, we put low-level control in the ECU, but you have some high level of control lying on the VCU, so they need to communicate. So maybe it takes time, and also sometimes it violates with safety because you have to break the message. You break it because you have to make different. You translate CAN to Ethernet and so on. So you break it. So it's so we have to consider, okay, in which case we need to keep break by wire, for example. Does that answer your question? Yeah. I'm going to talk about break by wire next week in Munich. So you asked the right question.
Yeah, so of course I need to ask a security-related question. As far as I can, you were talking about you have a security gateway for all the incoming communication. I mean, that's perfect. Of course you need that. But for the internal communication, you are basing the trust on like implicit properties. You know that this address is what you trust. Have you had any plans on going toward like zero trust paradigms in this area?
Yeah, we have a zero trust principle. Here is security gateway, I think. Oh, here, this one. So on everyone here, this VIU we can expose domain. Everyone from this domain can only talk with one part of the VCU. So we isolate them by VLAN, for example. It's 1K, and also in this inside this we have a switch that have a managed switch with a hardware security module where we can do the filtering, and we do different kind of firewall in the switch so that we know that only correct message can communicate. All the communication come from outside will be stopped, and then we generate a new one to send a new VLAN. Don't know if I'm not a security expert, and I'm very afraid of them.
Okay, I stopped then.
So thank you for the presentation. You mentioned that you are doing a lot of in-house software development. Could you give some examples for which ECUs you are doing the in-house development? So is it like the VCU here, or is it for the autonomous driving? Which parts?
In-house mainly, because it's our own competitive assessment. This VCU mainly in-house. This one, ADPM, we work with Zensak, you know, so they develop this autonomous driving module for us. Infotainment, partly, we develop in-house. For audio, for example, we are sourcing completely. VIU, we do in-house mainly. So many of the ECU we outsource, but the key box here we do in-house.
Thank you, and could you please once again say what is the VIU about? I forgot the abbreviation.
Yeah, maybe I will add that before you distribute the slide. VIU stands for Vehicle Integration Unit. So in this case, they make the CAN frame become Ethernet frame so that they can go to VCU. Because of service-oriented architecture, we want own Ethernet backbone. That's the reason.
Thank you.
I have also a question for the audience. Do you see any challenge that is not covered? Something that you expect but you don't see? Or you have a confirmation of everything? Or no surprises?
Thank you. So I'm wondering about the legacy software. I mean, there'll be a lot of legacy software. How would you transform it into this new architecture paradigm?
You touch my pain point. This is really painful. Many of those ECU are legacy software, the signal base. And that is the reason when we have to make this signal to service transformation. And the dependency, when you bring the old legacy software, then you have a lot of dependency, like a real-time and non-real-time mix, this kind of thing. Yes, a lot of dependency and also make it service-oriented. For new ECU, it's easy. All the infotainment are new, right? Infotainment are very, very new. You have to change all the time. Then they are easy to handle because they already designed in the new way. Automated driving is easy to handle because also designed on the new way. But steering, brake, all of these other control part are legacy.
Thank you. Just curious about the tools you're using to ensure traceability between requirements, system requirements, high-level, low-level requirements and testing, and that support your certification processes. I guess there are many guidelines that you have to comply with. Yes. If you can give us some ideas on that. Thanks.
Yeah. First, I'm sorry, I don't know much about regulation and what kind of tool guideline I'm not involved, but tool we're using, you know very well, System Weaver and Car Weaver. Electra, we use the vector tools like other OEM.
So I can say System Weaver is a software of a company that is called Systemite, that is in Gothenburg and is a tool provider for Volvo for a long time.
Hi, thank you for the nice presentation. I'm wondering about, for example, if you release a software, a car like 2020, and that software has bug, okay? And how do you fix the bug, and how do you propagate the bug fixing to the later version? You know, how do you do backporting, actually?
Yeah, we had to do that. If we find a bug, for example, in the test, we have a test car, right? For example, employee, driver, on this, we have a tool, diagnostic tool. So if I bug, we need to fix it and do it over software upgrade, over the air upgrade, in the software download. And we do regular, I don't know, cadence of how many weeks as I do this backward compatibility, or we have to do it in the car. But that's the worst thing with the OEM, right? If the news coming out that you have to take back the car to be able to change some bug, that's not good. So try to avoid that by testing many, many times before we can release a software.
Yeah, I think last question, and then we go ahead, because other food for thoughts will come later.
Yeah, thank you so much for this great talk. I have a question regarding like the porting between CAN traffic and Ethernet traffic. Can you give us any numbers about network characteristics like latency, or what is the rate of CAN?
Right spot on my work.
Oh.
So for CAN to Ethernet, if you do AutoSAR, it's I don't want to even mention. So the latest in the zone and architect latest numbers that done by a company in the CES, Consumer Electronics Show, 2.5 milliseconds, 1 to 2, you depend the polling, how often you poll the data. Right? For our case, we do the bare metal gatewaying. So it could be between the 500 microseconds. The packing actually only 50 microseconds, but if we do routing as well to see which can to go to which, because in CAN bus you don't have an address, right? You broadcast and then you send it. So about you can count it in the real life, 500 microseconds.
Okay.
In the bare metal. And autos are very low. If you comb stack every 5 milliseconds, you could have 6 to 8 milliseconds.
Thank you.
So I propose another applause for this nice talk and for the answer. So now, David, if you can come to add another perspective. And this should just come later.
Okay. Does these work? People can hear me? Great. Yeah, I want to give a slightly different perspective on things. Think about how many times you've been driving your car and a light goes on the dashboard that says something's broken. And you say, what? So you take it into the mechanic and they say, oh, it's not a problem. Or you take it in and they say, oh my God, why didn't you do that earlier? Or you're using the inbuilt navigation system and it's taking you on this weird route to get home. You say, why? Why is it doing that? In general, I think the user interfaces and the connection between the humans in the car and the automobile is incredibly primitive today. And this suggests perhaps rethinking a little bit about how the architecture could be designed to do a better job. So in general, as systems become more sophisticated, are doing more things on behalf of the user, incorporating intelligence of various sorts, we think of that as providing additional service. And in many cases, the goal is to get the user out of the system so that things can be done automatically, let's say parking or other kinds of automobile activities. But in general, I think we have to recognize that for almost all complex tasks, humans are going to be there somewhere. They're going to be part of the overall picture and have to work with the systems. And we see this in systems where, for example, even where we have auto-scaling in service-oriented architectures, we still need humans involved to specify various parameters to that. So if we look at, in general, many systems require humans and systems. Whoops, that's in the wrong place. Okay, well. So this, I think, leads to a couple architecture challenges. For example, in situations where things might be done automatically or might be done by the human, let's say parking, how do you decide, or how does the system and the human decide which to allocate to whom? How do you account for human natural tendencies to be distracted or busy or annoyed? How do you allow humans to know what's going on? Why is this light on that says my system is broken? How do you help humans guide the system when it's not doing the right thing? How do you get ways to communicate between the human and the system that's more than just a little yellow light flashing at you? So I think we have to sort of rethink in some ways the way software and humans work. And today, when we think about this, we can think of the system, and you have architectures like we've been seeing today, and you've got users out there that are somewhere out in the external universe. And today, there's a very impoverished notion of communication, that the user uses services of the system and maybe gets some feedback. And we can reason about various architectural things like loads and that sort of thing. But in general, the system doesn't know very much about the humans at all. And the human doesn't know very much about the system. And as a result, the communication, the coordination is really impoverished. Systems can't take advantage of human skills and knowledge. And humans are unable to understand what the system is doing and why. So I'm suggesting we need to sort of slightly shift our orientation here, where we think about bringing the human much more closely to the system, and where we think about our architecture, not just of the system, but of the human system coordinated composition. And we need to think very carefully about the kind of connections we have that allow this coordination to occur. It's not just the human's going to push some buttons, but there's a much richer form of integration. And similarly, the human needs to have a model of what the system is doing. The system needs to have models of what the humans like so that they can effectively coordinate. I think there was an interesting article in CACM that looked at various sorts of automation and contrasted the difference between Ultron and Iron Man, if you follow those sorts of Marvel movies, where Ultron was the ultimate robotic system warfighter that did everything you could imagine except when it didn't, and then it was dead. Whereas Tony Stark puts on this suit of armor and is able to augment his own capabilities. And I think we need to think much more in the latter form when we design our systems. So if we look at what does this mean from a point of view of architecting our software systems, I think we need to think about how do we build explanation in so that there's an active way for the human and the system to communicate, so the system can talk to the human and make sense about why certain things are happening. We need models that are runtime and adaptive models of humans in the system so they know who they're working with, what they can count on, what the human state is. And how do we also, particularly when we have automated things going on, how do we communicate, how does the system communicate to the human when it's not sure what's going on? A lot of the problems, I think, today, particularly in machine learning, are not just that it may misclassify, but that when it misclassifies, it's really sure about it. If it said, I don't know what this is what I think it is, then we'd be in a much better position, for example, to deal with that with complementary mechanisms. Okay, so my pitch here is that let's not leave the human out of the equation here as we're thinking about architecting for automobiles or any other system, for that matter, that's complex and increasingly automated. Thank you.
Any comments on that?
No, not comment, but for example, we have a drive monitoring system, which is a key function in this infotainment. So you're measuring the driver, and then you can know that, okay, this driver may be too tired or something like that. So somehow sending him a warning sound. So we do already have it. And I see in the future, a car is a learning system, right? It should get to learn the human driver.
So the question is, why isn't that in your architecture diagrams?
We do have, but it's just the infotainment part is not included in my talk, but a lot of research about this.
Right. But I think it needs to go very deeply. And we tend to think of, the HMI folks, the machine man interface people, they're going to fix it all. But I think that's not the case. I think we need to embed these models into our system very deeply so that the behavior is not just informed by the surface level interaction, but much more deeper semantic level.
Can you please give a concrete example where you see that human is missing in the system and the system is not learning from human, and actually human is not not the vice versa? Can you give a concrete example?
Yeah, well, we've done in our own group a lot of experimentation on how to give good explanations to humans, and mostly in the context of robotic systems. So a robot is carrying out some task for you, and they decide on some plan to do that. And you want to know why. Well, you don't want the robot to tell you, I have this Markov decision process with this utility function, blah, 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 right? You want it to be able to communicate at a level with the human that the human can understand that there's a domain of discourse. So you might say, I'm doing this because it's perhaps slower than the other path that I could take, but it's safer. Okay? So to communicate in terms of the shared qualities of interest. So that's the first point, is finding a level of discourse where humans and systems can actually communicate effectively. Second, one of the things we discovered just looking at human studies and then trying it out for robotics is that when you explain something to someone, if you say not just what you're planning to do, but why you're not planning to do something else. I'm going this way because of this, and I'm not going these other obvious or potentially obvious ways because this is what would happen. And it turns out when you do that, when you add in these additional kinds of explanation, humans understand 3 times as better than before. And so we need to think about that very carefully. What is the nature of the communication? How do we convey things so that humans really understand what the system is doing?
Is it my turn? Thank you for the nice presentation. So I'm a little bit curious, a bit confused as well. How does that impact the software architecture development? I mean, the problems that you talked about, they, in my understanding, they are more concerned with the behavioral models of the software. And I also agree with the previous presenter that there are many EU projects which have been working on this, like if the driver is drowsy, so how to communicate and so on and so forth. And there's a lot of work going on in the robotics domain based on ROS and so on. But maybe I'm missing the connection with software architecture, how the software architecture would change. Would it be some requirements or I don't know what?
From a software architecture perspective, if you think about, in general, architectures for adaptive systems, often you have runtime models. Some people call them digital twins, but other sorts of models that represent the system state and the environment state. And one of the things you have to do as an architect, design what is this runtime state that you're going to be using to monitor and adapt the system. So what is the runtime state that's actually in the system, and how is that state updated and used by the system? In the sort of adaptive systems world, you might call it the K in the MAPE-K architecture. But in any case, so we need to think about what kinds of runtime information do we have about humans? What's a human model? What's sufficient knowledge about the humans that we're interacting with? And it may be very personalized. So my grandmother might have a very different profile in my system than I do, and we would interact very differently with that kind of thing. So it means at runtime, when we think about the architecture, we need to think about how do we maintain and store and update these models that are going to allow us effective runtime interaction.
Thank you, David. So actually, I had a question that is very much related to what you just said about modeling humans. So a couple of days ago, together with Leto, Stefan, and other people, we hosted a workshop, and the keynote speaker was Professor Alfonso Pierantonio, that actually had this keynote on I don't remember the title, but the message was like, okay, are we sure we can modeling efficiently the nature, what we are observing? And the answer was, from his point of view, no. And then he was presenting a work that he's been doing with Bran Selic about how, yeah. And my point is like, because here you have models of humans, and as you said, they are humans in general, very hard to represent, to models. So my question is, which kind of adaptive models, if you are using, or maybe you think that can be used to model humans, or at least the interesting properties and behaviors of humans?
Yeah, so it's a very good point. You know, humans are complex entities, so what do you model? If I had a longer time to talk, I could go into what we do. I'm happy to tell you offline, but we've tried to pick very simple models, the simplest models that we could use in order to still be effective in terms of interacting. And we have something that we use very frequently called the OWC model, which stands for opportunity, willingness, and capability. So 3 variables. One determines, is the human available? The second one, is the human capable of doing things? And the third one, is the human willing to actually do it? And even with those simple models, you can get a long way. But that's just a start. I mean, I think this is where the interesting research is. And I don't have the final answer on it, and I think it does depend on the domain a lot also.
Actually, direct follow-up on the domain. I was wondering, David, do we have any good examples of domains where this thick kind of connector, we understand it better and kind of it works better than in other domains? Because maybe in automotive, you know, we already have a way to communicate things to users, right, in a car. I'm wondering, maybe there are other domains where they can be used as inspiration for furthering, let's say, furthering this research path.
Yeah, well, my slide isn't working quite right here, but you know, enterprise systems with security specialists. What do you do automatically? What do you turn over to the operator to handle? In the DevOps pipeline, how do you oversee the continuous integration of things? When do you involve a human to step in and do things? Driving.
But these are potential uses of, we have any success stories?
Oh, actual uses of this, yeah. Yeah. Well, as I said, we've primarily been working in the robotics domain, so most of my examples are from that. But we're currently working with manufacturing, Lockheed Martin, where in this case the human is the person doing the design of the system, and they need to, together with automated tools. So you have automated generation of various sorts of manufacturing plans, and you want to know, well, why this plan, not that plan? And the system should be able to explain it in terms that the designer would understand about strength of materials, flexibility, things like that. So that's the second domain. But this is a new area for us as well. I think we're just starting to learn about how to apply this.
So I think we can go to the next one, otherwise we will not have time. But keep in mind questions, and there is also the paper online where to write it. Because I think something that we are missing here is also the fact that we think on a drive, always on a driver. But there are also efforts. I know a company in Sweden that was trying a communication between cars and people outside the car. So if you have an autonomous car, what do we do as humans? We look inside to look the eyes to understand if they saw you. Then they were trying something, a car that smiled when saw you. No? And this is also something that you think in a different way, systems. So now,
Okay, thanks everyone. I think it was Friday morning when Patrizio sent me an email saying, would you give a talk at this workshop on technical debt and agile architecting? And I said, yeah, sure. And then I got on a plane in Seattle and I flew to Paris and I got stuck for a day. And then I spent a day traveling here. Then I gave a 4-hour tutorial. Then I talked to 1 million people yesterday. And then I woke up at 6 o'clock this morning with cramp in my right calf. And all recollection of Patrizio's original request had gone. So for some reason, you're going to get this talk instead. So technical debt is a really well-studied area in software engineering now. I think it's a well understood area as well. It doesn't mean that it's any easier for engineers to handle. Technical debt is just one of these things in engineering systems which is just inherently hard. You're always being driven by business value and the need to deliver functionality for users. And handling technical debt, cleaning up your systems, refactoring is something that inevitably gets pushed into the background. And so in that sense, technical debt is kind of like the gift that keeps on giving to the research community, because it's never going to go away. It's like, you know, organizing your vacations to keep your family happy. It's hard. It's fundamentally hard. It's never going to get easy. Earning enough money to pay your heating bills. All these things are just genuinely hard. And technical debt is an equivalent thing in software engineering. So anyway, so one thing that's always it's an issue I've mulled over for many years, is the flip side of technical debt. And that's what I'm calling technical credit here. And so I'm just I'll use this next 5 minutes or so just to try and give you an overview of what I think technical credit is, why it's an important notion for us to think about, and why as a community, as an architecture community, we're uniquely positioned to potentially study and make impact in this area. So, and at the end, you can write in the Google Doc if I'm crazy or not. So, context. Over the years, I've been involved in a solid handful or two of software system valuations. So these are cases when a software system is being either acquired or is being merged due to an organizational merger. And there's money changing hands to acquire this system. And the people who are going to buy the system get a bunch of experts together, somehow I get in there, and they say, tell us if this software is any good. Does it do what it's meant to do? Is it built well? And all sorts of questions like that. So basically you're doing an extended code product review. And in the architecture world, we can think of this as kind of an ATAM or a software architecture analysis, all the methods that we all know and love. And also you can run tech debt quantification tools on them. So this is, you know, the sort of consultant's dream. You just run this code through a tool. It tells you this product has 11,000 hours of person engineering technical debt, and you just give that to the people who are trying to acquire the system and say, give me your money, thank you, it's wonderful. But there's other issues that lurk inside this particular problem. All software systems now, and I think it's very close to all anyway, are built on some sort of foundational framework. And these foundational frameworks, and most systems have multiple of them, anything complex anyway, they embody architectural decisions. You choose to use Kafka, you're choosing to build an asynchronous messaging, event-based system that you can potentially scale, you can secure, you can stream, you can do analytics on streams, etc. You're building a system that can do all of those things kind of because you're using Kafka. And Kafka's just one example. There's a zillion platforms out there. But because you're embedding that software into your system, you are inherently adopting the architectural decisions that have been made in those products. And there's multiple alternatives as well. You don't just have one. You can customize and parameterize these products to behave in certain ways. But they're all kind of, you know, the main architectural thrust doesn't differ. So this is something that a technical debt tool doesn't know about, because this is software you're using, you're acquiring, you're embedding into your system. And often you can do wonderful things with just a couple of lines of beautifully constructed code. So, you know, technical debt just doesn't know anything about this. So some of the ones I've seen as I've done these projects is, you know, we've had software systems that are built on Kubernetes to support application deployment. A fine thing. What about using DynamoDB for storage? Well, yeah, Dynamo's great. Kafka, already talked about. Blockchain, everyone uses blockchain. It was meant to solve climate change, I heard once on NPR. So it must be worthy. And there's infinitely more possibilities of products that you could use, platforms you can embed into your software systems. But the important thing is, none of these platforms are inherently good or evil. They're just software platforms. And it's what you're using them for that dictates, the context that you're using them for, that dictates if it's a good idea or not. So this is where the difficulty in evaluating and valuing these software products is, because you've got to understand the context that they're being used in and potential future contexts that they will be used in by the acquirer. So you can't really value something without knowing what you might want to do with it in the future. Context is everything. So I drew this diagram this morning, and I realized about 20 minutes ago, it looks like a jellyfish, but you know, you'll figure that out in a second. So down here we have the current architecture. I haven't got a, oh, do I have a, oh shit, no, I don't have a pointer. Has it got a light? Yeah, oh yeah, light. So here's the current architecture. This is what you're evaluating. It's got embedded stuff in it. It doesn't really matter what it is. And then there's all these future possible, desirable deployments that this software may have. There's a spectrum of them that the software system could possibly be used in. And let's say this is a target domain for a particular system. So if we can move this current architecture to actually satisfy that domain in a reasonably positive way, we can value it highly, because the architecture is facilitating this transition from its current usage to some future usage. So imagine a billing system that's being acquired, and it's going to then be embedded in some mobile payment system. That's the kind of usual sort of thing that we've looked at. A billing system's not going to be suddenly transformed into an intelligent car driving system. These things don't happen. You can usually project what's going to happen to your system in the future. But there's obviously an alternative where another target domain, the architectural choices that are embedded in the platforms in the product, are less desirable. They don't facilitate that move so well. So your product has less value because it's not built in a way that it can be transitioned to satisfy future requirements. So in this case, our architecture is increasing the value of the product, and in this case, the architecture is decreasing the value of the product. But it all depends where your targets are on the jellyfish eyes up there. So this is what I call technical credit. It's the architectural features, the way an architecture is built, that facilitates potential future uses. And if you can draw a line between the current development and the future development and show how the architecture can facilitate that deployment, then your product has high technical credit. The alternative is, if it inhibits this transition, it has low technical credit. So I've done many of these, well, solid handful or two, let's say, it's plenty. And I've always struggled with how you quantify this. So there's obviously some technical component, and there's obviously some business component of this technical credit thing. And I've never quite known how to actually fully quantify and express it. And how really you evaluate it. There's obviously some quality attribute stuff in there. There's obviously some framework options. There's obviously some business domain compatibility features. There's other things as well. It's a complex beast. It's a complex multifactorial beast that we're trying to quantify here. And how do we rigorously quantify it? And how do we potentially compare this technical credit value across potential futures? So that's really all I've got to say. I think it's a hard problem. I think it's a problem worthy of study. But like I said, I could be crazy. Thank you.
Question? Do you think it's a good idea, or is it crazy?
Hands up for crazy.
So let's see if I got it.
Oh, okay. Can you unmute?
Antonio? Yeah.
I'm not sure it was well, just a mistake.
So I continue. So let's see if I understood. Basically, you're saying we use a particular technology because we expect to have some value. And this should be the credit. But we don't know exactly if this will be good or bad. So this remember me some years ago that I was working with Ericsson in Gothenburg, and a guy called me and said, "Oh, look, within the company we have we are split in two parts: people that are more agile, people that are more model-driven engineering. I would like to have a definite answer. So let's try to use models for real, and let's try to put in place a good experiment, and at the end we will have some evidence." Because somebody said that if you do that, you will have good reusability and quality, but I'm not sure. Can we do that? So we failed, because it was so difficult to have evidence. So what I think is that for this kind of question, it's a very good question, I like it, but it's very difficult to answer.
Yeah, it goes back to one of the quotes that Paris used, one of the classic quotes from Philippe about architecting is a constant set of decisions made partially in the dark. You're kind of hypothesizing what a future need for a system is, but someone's willing to pay money for it. So then this sort of hypothesis actually needs to be grounded in something concrete and something rigorous, so that you can actually say if the money that they're going to pay is worth what if the software is worth the money they want to pay. So it's actually really quite a thorny issue. Thank you.
The argument you're making makes a lot of sense to me, but it also is very resonant from the past arguments about product lines, with the same potential downside, that it requires someone to invest. And the people doing that investing, the incentives are not always for the people producing the current product. And so there's an organizational challenge, who gets the credit for the credit, that I think often goes way beyond the technical issues. And this, I think, is a serious concern when we think about the broader ecosystem of this sort of thing.
Yeah, I mean, there is some product line analogy there, I guess, because software systems are obviously easier to evolve in a way that they were into a domain they were intended for, and to be customized in that way. But when you're acquiring a system, for example, or you're moving it across a different business domain, then often it's just looking at the actual underlying frameworks and design to see if it can be transitioned. It may not have been intended to be transitioned into that domain. An example, one of my PhD students sold a company, and she flipped 3 times before she actually sold it for a few $1 million. And every time they did it, they had to figure out if the way they built the system, it was possible to flip it to the new domain. And luckily it was, very, very easily, because they built it in a certain way using certain platforms. And so that, to me, had a lot of technical credit. And I said it ended up being worth, $20 million.
Okay, so we have also a question from Antonio Martini, if online. Don't know if you want to, okay, unmute, you can do the question.
Hi all, can you hear me?
Yes.
Yes, hi, and thanks for the nice presentation. And I'm sorry I cannot be there, but in person, but personal issues. So no, just a quick question, because technical debt is one of those things that, like you correctly, I would say, mention, it's down prioritized. Even if we try to make it, a financial threat in a sense, it's like, okay, it's technical debt. This must be definitely repaid, and it doesn't work. So. Because, it works, meaning sometimes it gets prioritized, sometimes it's not. But the whole metaphor is to basically try to make it more relevant. Do you think the credit metaphor is going to make it easier to accumulate this credit, or can it be more or less difficult than technical debt to be prioritized? Or what do you think? I haven't used it in practice. Did you try to convince someone to give you credits, technical credit, or?
I don't know is the answer. Like I said, this is something that has become apparent to me as I've been involved in these valuation projects as a consultant. it's something that does resonate with people. It resonates with the technical teams, it resonates with the business people, but I've never been brave enough to actually quantify and characterize technical credit in a rigorous way. And that's why I'm kind of hoping someone can help me.
Do you think it's going to be similar to the technical debt or completely different then?
It'd be interesting, it'd be cool if it was as resonant as technical debt. I mean, but we're a bunch of engineers, we always see the negative side of life. So.
Thank you.
Very quick question. First of all, thank you so much for the nice idea. Building on what David said, do you think that this idea of technical credit can be linked to, for instance, reference architecture or software product line architecture, in the sense these kind of tools may help, as you say, in achieving a higher technical credit?
I think there's definitely work been done in product lines and reference architectures that can help. The cases I've seen have mostly been either startups being bought or mergers and acquisitions where a company has said, we're going to buy this other company and we've got to figure out how the hell we're going to use its systems in our systems, or we're going to integrate them into our systems. And in one case, the software systems had been built by the company that's being acquired in a really super flexible way. And it increased the value significantly of that company. Whereas another one was just a bunch of old legacy systems, and people said, shit, we don't want to touch those. Get the fire extinguisher out, you know. And so, I don't know. I've not had a chance to think about this and crystallize it, but I think there's something there of value. And I think it's something as a community, because it is definitely linked to architectural characteristics and architectural features and quality attributes.
Yeah.
So I think, you know, this is a good community to maybe think about it.
Yeah, thank you.
That must be time. Yeah. Next panel. Don't move, David.
So I think we need to close, but I would like to thanks again all the participants and you as well for all the questions. And yeah, now I don't know who is chairing the next section, but there will be the panel. Yeah. So.
And while everybody settles, let me repeat the announcement. The buses will leave at 7:30 from the fountain, 7:30 sharp. So please be there. There will be 3 buses. We have an awesome student help. For those of you who are a little late, there might be transportation, but I wouldn't count on it. So be there at 7:30. Right. Well, welcome to our panel this afternoon, where after all the conversations that we've heard, especially the keynote we've heard this morning that came from industry, we'll be talking about the challenges and opportunities in educating the next generation of software architects. So I'm going to start with a little question for the audience. I'll read my questions first. I would like to all to think about, and you're all going to pick one category among the questions I read. So if you were to decide among the roles that lead your role, would you identify yourself as someone who would like to go into industry as a software architect, who's already in industry working as a software architect, who's in industry mostly hiring software architects, who is in academia educating software architects, or who would like to go into academia to educate software architects? I'm hoping I covered it all. So the challenge is you can pick only one, and we'll do a head of count so that we understand what kind of an audience we're talking to. So how many would you like to go into industry as software architects? Come on, don't be shy, we can see. 1, all right, 2, 3, 4, 5, 6, 7, okay, 8-ish. Who are already working as software architects? This is going to be humbling. 4, okay, more than I expected. 4, 8. Who is in industry or any other domain hiring software architects? Okay, so 1. And actually I forgot one category. How many are helping others architect? Other politically correct way to say this, consultants?
I guess so.
Okay, so yeah, right. Oh, you raised your hand twice. That doesn't count. See, I'm looking. All right, so then maybe who are educating software architects? Right, we have mostly a crowd educating software architects, and who would like to go into academia to educate software architects, want to become professors. One person? Right, so obviously today, within the next hour 15, okay, now you're all rethinking your answers, right? Identity crisis. We'll explore some of the expectations of industry as well as academia in terms of what does it mean to grow and hire software architects, and how can we currently prepare the next generation of software engineers in these roles as software architects. And we'll reflect on current state of the practice, some of the challenges my esteemed panelists might face or they think is coming towards us. And ideally, this is a conversation for all of us. I am incredibly fortunate to have really a lot of experience here. So what I'll do is I'll just give a one sentence why I invited each of the panelists to be part of this panel, and then I will position what are the key challenges that they observe in their practice today, and then we'll get it started. David Garnon. David and I go a long way. One of the reasons I'm in software architecture isn't David, in fact. He's a professor at Carnegie Mellon University, an associate dean of School of Computer Science, and one of his roles was, until recent past, directing the Master of Software Engineering program that both received a lot of industry as well as groomed industry, software engineers as well as software architects. So that's where I thought there was some relevance there. Patricia Lago, professor at Vrije University, Netherlands. She also works a lot with industry, both educating software architects, but also working with industry in terms of research. One of the reasons we had this morning's keynote was through Patricia's connections, both from her work as well as from her studies. Professor Uwe Zun from University of Vienna, Austria. Uwe thought I invited him as a professor to the panel. No, in fact, I invited him because he recently released a book, Patterns for API Design, coming from academia for software practitioners. So there's some good transfer there between different domains. Eljo, a good friend, we go back, and we are in the category of helping others architect together from CGI Netherlands, and he is leading a team of consultants who are helping architects architect better, educating architects, and bring some of that perspective as well as hiring architects. And last but not least, Ian Gordon from currently Northeastern University, but he also has worn multiple hats in the past, working in industry, educating architects, but also writing for architects, software foundations of scalable design, a key challenge. With that, I'm going to stop talking and turn the voice to my panelists. So what are some of the current challenges that you observe and you see, and how do you think we can do better for the next generation, educating next generation architects? Maybe we'll get started. Elcho, if you would like to take the lead, and then...
Sure. Yeah, so I have, I am a consultant, yes, I help architects architect. I also give training. I have given architecture training to hundreds of individuals. And some of them get it, and some of them don't get it. The biggest challenge, of course, is when they don't get it. And when I think about what is the difference between those that get it and those that don't get it, it's mainly one thing. Have they seen things go to hell? Those that have been in software engineering or in software development and seen things really become difficult and go wrong, those very quickly grasp the architecture material. And those that have not seen it, it's very, very difficult. So I think the biggest challenge is in educating software architects, I don't know if you can educate them, but make sure that they have seen things go wrong.
Thank you. Patricia?
I don't have a mic. can have two.
Oh, I have two microphones. Thank you. I think the biggest challenge remains the human side of the profession. I hardly see, or I can't remember any actually, higher education curricula which seriously combines technical competencies with skills like communication, like interpretation, system thinking, critical thinking, etc. And we all choose computer science and eventually become software architects or the like, thinking about the technical side. And then things go there, so go wrong because there is a lot of misunderstanding. So we should create competencies that are in the human side and the creativity.
Thank you.
Yes, let me start by being a professor for a minute. Just the two things you have said. I think where we have the biggest impact potentially is actually the many students we educate as professors. But actually the impact is, in my view, for many reasons slim. First of all, we cannot teach all the things we would like to teach, because usually in most universities, there are some places that are like heaven, where you have a software engineering degree and a lot of software engineering professors, but in most places there's one software engineering group, right? So you try to get the software engineering stuff into the curriculum, and I think we're doing good in the core topics, but then topics that go beyond this, you can only touch, if at all. No? So things that go wrong, soft skills, practical, hands-on, project-based learning is only a tiny fraction of the curriculum. And one big challenge is that a lot of our faculties, let's say, are not really into these topics, and it's very difficult to push these things into curricular and also into our colleagues. The second thing, which relates to the book and other things, is what you can do in research. And here I think the biggest thing actually is people movement. So the people here in the room that have raised a hand to your first question, I think this is actually the biggest impact we can have in academia, so that people move from academia into industry. And there's also this impact project, there's an ACM website on it, that shows that this is actually where we can make a big impact on practice. Then working with practitioners, like writing professional books. I was crazy enough to write 4 of them. The latest one you mentioned. The involvement in IEEE software is also for, this is all a labor of love, yeah, in a sense, yeah. So you don't do it for the things that are actually counting as, so if you think about an academic career, you should not do these things, but I think they are very, very useful. No? There are a number of other things which are more, let's say, valued, like collaborative projects, for instance. So if you work directly with it and brings money into the system, it's good, no? So that's something that is liked by the universities. But in general, let's say for your age index, writing books, working with practitioners is not a good idea. No? And I think one of the biggest challenges in our life is, as an academic, that there should be more incentives to work with industry.
Mm-hmm. And, David, let's make it up your slide.
Oh, okay. Last night, as I was thinking about this panel, I remembered the first course I taught on software architecture, which was in 1992 with Mary Shaw. We were trying to figure out what is software architecture, and we thought the best way to figure it out would be to try to teach it, and that would actually help us understand that better. So that's 30 years ago since we've been doing this, and still teaching it, and it's nice to reflect back and say, well, what's really changed over those 30 years? And I think there are 2 main kinds of things that I think I'd like to emphasize. One has to do with what do we mean by the architect anyway? And second, who should be doing architecture and what does that involve? So, so I used to draw this picture here, if I can make it work. Do I need to be closer? Go next. this sort of picture where we have requirements and implementations and architecture somehow lives in between that allows you to get some kind of confidence that what you're going to build will actually satisfy the requirements. Could you go next one? And the architect is the person who does this. So they're in charge of filling this box up with useful models and other things. Next. No. Today, I think, is quite different. Next. Instead, when you do architecture, you're not starting by filling an empty box. You're working with frameworks, with building blocks. Next. Keep going. Keep going. Keep going. And eventually, you plug in some application-specific part that's actually your piece of the puzzle there. And so what does that mean? Well, it means the enterprise of architecting now involves not just sort of thinking from scratch what architecture is, but thinking how do you integrate these pieces and understanding the architecture implications. Next slide. If you think about who's involved here, there are a lot of people now that have to be involved. They're product managers that need to understand where is the product going to be going, what versions do we have. There are framework designers. You may need to build your own framework. There are framework integrators. There are programmers who have to program these things and understand the architecture constraints associated with them. And there are even end users who may need to configure the system. So now all of a sudden we have a much richer population of people where architecture is important, that they know something about it. Not all knowing the same things, but many of them knowing something or enough to do their job. So I think that changes the equation for how we teach things and what we teach. Next. These are things that I always struggle with. I think we can bring them all out here. So one is an architecture mindset, I think, is very hard to teach because it involves thinking very differently than a programmer. It involves thinking about end-to-end qualities that involve a sort of system-level perspective. And that may sound easy to say, but I think students struggle to get that perspective. Second, today, many of my students go to work in industry and are very frustrated. They want to do architecture, but they're doing it in an architecture-hostile environment where the only thing that's valued are sort of feature velocity. And the thought of actually doing good architecture design they're swimming upstream, basically. And the question is, how do we teach them to cope with that environment? How do we actually get them to advance architecture, even in the face of those kinds of pressures? And I think there's some interesting resources here. One that I've started to incorporate pretty actively in my teaching are something called architecture decision records, which tend to democratize architecture and essentially distribute the decision-making across the team and produce a process where incrementally you're developing architecture decisions and socializing it. So everyone is responsible for architecting, not just the architect. I think there's always the struggle in a finite course. How do you balance general principles and specific techniques? People going in industry say, well, I'm going to need to architect cloud computing systems, so you better teach me that. But if you do too much of that, you end up not teaching the fundamental principles that will apply across all domains. And yes, I think I mentioned that. When people go into industry excited about architecture, you have to give them the skills, the social skills, the technical skills, so they can actually force architecture or cause architecture to happen in those organizations.
Ian?
Yeah, so I run a Master's Computer Science coursework program in Seattle I've got 600 students in the program, so that means about 200 graduate every year. We're actually in the heart of Amazonia in Seattle. Some of you may have been there when ICSA was there. And we're literally surrounded by Amazon and Facebook buildings, and they're all coming back to work now, which is good because the food trucks are coming back, so you can get lunch. But all our students desire to work in these organizations, and the only way you can get a job as an SDE, a software development engineer, in one of the high-tech companies, the big 5 or 6, is to do 1 million leak code exercises and be great at writing code on a whiteboard and designing data structures and everything. So that's very much what our program targets, very much as Patricia was describing in a negative way. But this means there's really just not enough time to teach them any of the human side or the design side or anything. So as most of the students pop out of the program, they do my course, which is called Building Scalable Distributed Systems. And it's an exact opposite of everything they've done so far. We don't write much code. I tell them, you're not going to write much code, but you're going to understand things, you're going to measure things, you're going to deploy them on the cloud, you're going to beat shit out of them with millions of requests a second and see how they behave, see how they fail, see how you can configure them. Try and understand how internally these platforms work, because you don't write these things, you configure them. And they all kind of love it for some reason. I don't know why, because it's really hard and they spend days on my projects. But it seems to be the one thing that has actually instilled some architectural knowledge in it, because we do try, even though I don't teach it architecturally, they are learning about architectural principles and architectural qualities as they actually build the assignments and watch, and as Elcho said, watch things fail. And they realize that they can write 1 million lines of code, but if they don't get the 1 line of code right that configures the platform correctly, it's never going to work. So if you want to know all about this, you can read my 4th book, published by O'Reilly, Foundations of Scalable Systems. Published July 2022.
So the key to teaching architecture is to not call it architecture, but call it some sequence of buzzwords with scalable and...
Yeah, yeah, it's true. I mean, I don't tell them about architecture. I never mention software architecture, really. And just an anecdote, one of my students came to talk to me last summer. He'd been working for a year. And he said he went into an interview and they started asking him questions about, kind of architectural questions about asynchronous systems design. And he said, oh yeah, in this course I did with my professor, we use RabbitMQ. And they said, oh, that's interesting, we use that, tell us about it. So he started telling them about it. And he's told them what we did in the assignment. And he goes, oh, that's interesting, tell us a bit more. So he wrote down some of the code that he'd written in my assignment. And after about 10 minutes, the dude walked out of the interview, said, I'll be back in a second. He came back about 5 minutes later, he said, we don't need to talk anymore, we're just going to make you an offer. So it made me very happy.
Any questions from the audience anytime? If not, I'll just keep asking questions. So, what are some of the engineering questions? Oh, there's one. All right, sorry. They don't want my questions, that's good.
Neil's question.
Neil question.
Okay, so one skill of architects that I think is important was not mentioned at all by any of the panelists. Patricia and David both got dangerously close to it and both veered away at the last second. And so I'd like to hear your thoughts about the importance and how you teach the communication skills that are so necessary for architects.
I have it.
I knew you would.
Right. Who would like to take?
Maybe I can start. Well, I wanted to link a premise is that it's becoming a challenge more and more over time because of the growth in the number of students. But there are many ways in which we do. So first of all, projects from industry and with the industry. So students work in project and then they have to defend their own design decisions and discuss with the practitioners, compare and contrast with other teams of students, etc., etc. But of course, this is very effort consuming. So if you have 5 teams of students or you have 50 or 100, then it starts to be impossible. And the second thing is to really teach critical thinking. For example, I have a new course that I'm experimented with in which you really implement debates based on strong literature, strong theory, but then the students have really to develop this type of thing. So if I have a position of, I don't know, what I believe rather than a certain reference architecture, then how do I defend it and how do I assess the pros and cons, and if some others disagree, how I think about that. So all these type of methods exist in teaching. We have just to use them, I think.
Also, we have a question from the remote audience. I can read it. I mean, the challenge is how to balance teaching the knowledge of new technologies and the fundamental concept of software architectures.
Right. So let me repeat the question. If I heard it correctly, how do you balance teaching fundamentals and what was the first part?
And the fundamental concepts of software architectures.
And what was the first part?
And teaching the knowledge of new technologies.
Teaching the knowledge of emerging technologies and the fundamentals.
I can do that one. That's easy. I mean, you just pick a technology that's representative of a class of technologies. So, messaging, we use RabbitMQ and Kafka. Streaming, we use Flink. But you don't just teach that particular technology. You give them a good overview of the general capabilities, why you use these technologies, what they do in general, and then you say, right, and now the assignment's going to use this one. You can use another one if you want, but we don't know why it works, so you're on your own if you do. And sometimes they do, because they're crazy. But that's an easy one, to be honest. There's a class of 10 key architectural technologies or something that you need to teach people, and there's a good representative technology of each that they can learn. That's not hard.
We ask our industrial partners to do that for us.
So in general, for these things, we try to find knowledge sources that are old knowledge, like patterns, best practices, and teach these things. And then, like Ian said, use one representative technology so that they can realize something with it to get hands-on experience in a project.
Yeah, we don't teach them about technologies at all because we're too expensive for that. We ask the vendors to do that. Yeah. I want to get back to Neil's question about teaching communication, because I think that's a very important one. Some of you may know Philip Kruchten's paper on what do architects really do. And in his research, he found out that actually architects spend 50% of their time on communication and only the other 50% on what we normally consider architecture work, like modeling or decision making. And that means that if you are not very good at communication, you can never be very good at architecture, right? So it's key. And what we do is we specifically, when we train our architects, we specifically focus on communicating to business stakeholders. And we do that with lots of exercises. We have a 3-day program which has 5 exercises all about translating your work as an architect into business language, like translating the impact of architectural concerns into business impact, translating architectural, the criteria for making architectural decisions into business criteria, explaining why you need to get rid of this technical debt in a business case, etc., etc.
So maybe that's yeah, go ahead.
I agree with the co-panelists here that sampling is necessary, but I think sometimes the best way to use technology is to force people to see where it breaks. In other words, what are the things you can't do with it? You ask them to, make some modification using some particular architecture framework, and then you ask them to do something which is going to be incredibly difficult to do just because the framework won't let you. And I think that's an incredibly instructive way to use that kind of thing.
Can I offer one more perspective on the communication aspect? One thing we observed actually in an article we wrote with Olaf Zimmermann and Gregor Hofer is that nowadays there are quite a lot of skills that an architect needs. No, it's not technical skill only, it's also communication skill, creative thinking, things that have to do with working with various stakeholders beyond communication, for instance, leading of teams, and so on and so forth. And these things tend to grow and grow over time as the technologies and responsibilities. And one observation is that in many cross-functional teams that you see nowadays, actually this role is split into different roles, and different people take this role. So you cannot expect one person to have one person who can do all these things well. That's or very seldom that's the case.
Yeah, I think it goes back to the point that David made as well. There are now multiple individuals with multiple hats, multiple roles that might share or have a stake in, or perfectly valid input to some of the architectural tasks that go on, which maybe is part of the challenge. Go ahead, Ilyas.
Direct follow-up on the communication.
Well, let's wait for the...
Yes. On the communication, I have a bit of a strange idea, but doing a PhD involves a lot of communication too, right? Do you think that actually doing a PhD helps you become a better architect by this indirect effect? I know it's a little bit strange, yeah. But I have seen, for instance, the case in some companies, right, or in some projects, European projects, that the people that play the role of the architect may have a PhD. That's why I'm asking.
Yeah. So. Yeah, what I notice is that being a good architect requires critical thinking. It requires basically a scientific mindset, because you always need evidence for your choices. Otherwise, you won't be able to defend them, and you won't be able to trace them to the business goals. You always need to think of alternative solutions, because you can't just assume that the first one that comes to your mind, right? So there's a number of skills in the scientific mindset that are incredibly useful for being an architect. But on the topic of PhDs being good communicators, I think we can have another discussion about that.
Oops, all of you are doing PhDs. Any other input on that? Or?
I had this point about people movement, and that it has been actually shown in studies that this is actually how knowledge is transferred. I think it has a value that you have 5-6 years to work on a topic that you choose and go really the deep dive if everything goes well. And that it brings another perspective to industry. That doesn't mean that people who chose the industry path and worked all the time in industry are better or worse architects. I don't think so. No.
Right. So we've been talking quite high level so far. Let's maybe get a little specific. What are some of the enduring topics of concern that need to be offered to students in software architecture, or early career individuals in your case, Aljo? And what are some of the new subjects area of curricula that need refreshed? Should we all be teaching ChatGPT? I don't mean that. But
I can start.
I didn't think it would be a hard question, but...
No. I will limit myself, because otherwise it seems that we don't teach anything at all. But I think there are two big misses in current education. One is, actually Elcio mentioned in the conference already a couple of times at least, that I heard that architecture is context, is implicit. So we don't model that, we don't link to the architectural element. And I think this is a big mistake, because it makes technically unsustainable. And when we, I don't know, reuse, or when we move or redeploy any solution architecture or any system, then we have big problems. So making explicit contextual elements is not touched, and it's actually also a research topic, I think. And the other thing is we forget that also architecture is guidance. Maybe it relates back to communication, but I think we forget to link architecture and reference architecture and representation, etc., to the role of guiding any type of stakeholders of the architecture itself.
ML pipelines. It's the hottest skill around in Seattle right now, and it was validated by a friend of mine who's fairly senior in the tech industry around town. He was one of the original architects of the Cortana system for Microsoft. Okay, nothing to be proud about. But he redeemed himself by going on to work at Alexa, and he's just moved to Meta into the VR camp now. He gave a talk to my students and basically said anyone who can help architects and design and deploy ML pipelines is worth big money. And he gave some nice, insightful views into why, not only why this is the case, but why it's an important skill. And he openly said he had never trained a model. He'd built Cortana, and he'd built half of Alexa, but he'd never trained a model. But he understood the qualities of the models. He understood how to integrate them. He understood how to make them fast. And he understood the different properties of different types of machine learning. And so I think those types of skills are absolutely essential for future architects. And I know CMU has got a course in this, Stanford has, we're hopefully going to have one next semester. It's a hard one to get people to teach because it's really multifaceted and multi-skilled. I could teach about a quarter of it, but I can't teach the whole thing. But if you want to earn big money, trust me, that's where you want to go.
Well, go ahead. Well, there's the big money, but there's the new skills aspect of it, right? Because the models are here to stay. So let's. Were you saying something else?
No.
Right.
No, I commented that we teach from this year, so we're good.
Okay, that's good. But what are some of the enduring topics of concern that we should not let go while we're making room for new topics as MLOps or other?
Well, I think coming back to my original sort of what is the biggest challenge is to get people to experience things going wrong. And I think David actually gave a great tip there. Ask them to do something that's almost impossible. And then they will learn how to deal with that. So maybe that's something that needs to stay.
Because my panelists are not taking, I'm going to maybe make a plea, and then please teach the difference between architectural significant and non-architectural significant, because that skill goes really a long way, and there are quite a number of people that come with fat resumes who do not know this.
Until now, we have seen a lot of arguments, and I fully agree with the arguments that people have to see things breaking, and also that an architect needs skills for communication. What I'm not I heard until now is architecture is not a path between, okay, I go programming this way and architecture is this way. An architect should be an excellent technical person. So before you can do architecture, you first have to do your basics. So from my perspective, I teach my students a lot of things like patterns and other things. This is great. But at the same time, I tell them, if you go to the industry at me, you first have to work 5 years as a software engineer. Because I don't want to see in industry someone with the label of an architect without the necessary base experiences before. So I think this is important to teach the people that architecture, yes, is a path to your career, but it's the second step. So even when it comes to a PhD, no, it doesn't matter actually. What matters is between your PhD or whatever you do, before you become an architect, do your basic experiences. And this means, from my perspective, doing at least 5 years of experiences where you get your hands really dirty, down to the code, down to the basics, and then become an architect, because then you are prepared. You have seen the things breaking in 5 years, because it will be broken. And another important point for architects is not just to see things breaking, but you have to build them up again once they broke. So it's important to do things like creating walking skeletons from scratch. It's true that frameworks and other things help us a lot, and yes, it's true that an architect today has to integrate a lot of things. But to educate an architect, you have to give those people the possibilities to build from scratch a walking skeleton, and this way integrate frameworks and libraries from scratch. This is really hard, and this teaches this experience teaches you, from my experience, the most. But most important, let people understand that they need experience before they become an architect.
Great, that's
Anybody wants to?
Yeah, anybody wants to disagree?
I
want
can give a counterexample, but only because there are many architect roles in the digital world, and they're not all software architects. And you hear things like solution architects, domain architects, etc. And I've seen very good architects of digital sort of landscapes and systems that had never programmed a line of code. One of the architects in my team used to teach Spanish, and learned a lot of skills that she could use, sort of moving to the architect role. Of course, she needs to compensate for not having that technical experience, but still, it was easier for her to pick up some of the key lessons of becoming an architect than it was for me to teach somebody who has learned programming and learned software engineering but has never seen anything go wrong.
There were a couple of hands, so I'll take that, and then Neil, you had your hand, and
I wanted to.
Oh, sorry.
Okay.
Well, hold on. Yes.
Okay. When I teach software architecture, I understand, for instance, I teach the master. And if I have students that have already some experience, it's completely different. They love the classes. And students that come directly from the bachelor, so-so, okay? But the ones that really have experience, that they really love the classes. And my experience is that it works better if you teach software architecture like you teach law. You pick cases and you discuss the cases in the class. And there are good sources about, for instance, architecture for open source systems. And so you can find what is the architecture of infinite span? What is the architecture of, so all these open source tools where they describe that. And you can spend a class or two discussing, because you see the different decisions, and it works, but works better for the ones that have real experience.
So I guess a theme is emerging where experience really matters here. So you can't necessarily just transfer knowledge. You have to give some time and experience and opportunities for the experience. Patricia?
Yes.
And then...
Yes, I wanted to comment because we didn't mention before, because we were talking about education. So in theory, at least, on average, I think experience comes right afterwards. So when I moved to the Netherlands 21 years ago, at least at the time, but I think it's still valid, the architects, whatever version of that, Dutch architects were famous to be very good because they had a technical background and building on top of that. My comment is that it's not only about the technical competencies, it's also about, again, the soft skills. There are surprisingly more than 94% of our students that already, since the bachelor, they work during their studies. And there are a few of them that when they exit, they are excellent junior architects already, thanks to that, but also thanks to the skills that they have. And this is maybe innate, or maybe we can teach them. But without the technical competencies, without the rest, is also not a good combination, I think.
Okay, that's what you were referring to, that experience and technical competence in others. You had your hand up.
Can I?
There's one, Brown.
Okay.
You can't. You're banned.
Can I just enter?
yes. Go ahead.
Just one sentence. We have the same experience. Also, many of our students are working half-time, for instance, for years in the industry. And so I always tell them also you need experience, but many have already experience. Also, one other thought that I would like to add is we have also people who, when they come into the studies, have already years of experience in programming. They have often started as a kid, or we have in Austria also schools which teach programming. and it's sometimes in these university discussions an elephant in the room that you should not mention that some people are already, when they start studying, are very experienced, and others see a program the first time when they have the introductory programming course. And that's, of course, something which is a big challenge in computer science education. No?
Yeah. Yeah. We are not able to hear. We cannot hear.
My main observation is that architecture is something that can be learned, but I'm not sure if it can be taught.
Okay.
Because it's like research. We don't get our PhD students in a classroom and we teach them how to do research. They just sit with us and watch us doing research. And they grow up and eventually they become researchers. So I would guess that a good way of teaching, learning to be an architect is getting involved in the workshops and very practical, very hands-on kind of training. It's much more than the kind of notations or abstractions that we make. And that's something that had
Okay. So the perspective is architecture can be learned, but it cannot be taught. Agree? Disagree?
I don't think so. It's not that the profession of architect is that special. In any profession, I think there are personal skills innate, as I said before. So you cannot teach a person to become a medical chirurg if he or she is afraid of blood. So you still teach people to make operations. I think also an architect, I mean, some learn during their computer science or other studies about software or digital architecture, but maybe that's not their destiny. And some others have the right competencies in life and that they just pick it up and then they develop in the profession.
Yeah, I mean, I just emphasise what Patricia says. Despite EPEC thinking I move jobs all the time, I've actually been at this one role for 8 years now. So we've got plenty of graduates in industry, and it's actually the 10th anniversary of our campus right now. So I'm getting in touch with a lot of the grads, and it's interesting to see where many of them have ended up. And the ones that have big personalities are really the ones that have evolved to be sort of senior designers. And Amazon doesn't have architects, but you know that's what they really are. They're designing stuff for big teams, multiple teams, but they've got personalities, and it's innate in those people. Just as Patricia was saying, we didn't teach that. They were the outspoken ones. They're the loud ones. They're ones that led teams in college, and they're just built to be people who can do this kind of role. And so, in that sense, yeah, we didn't teach them that. So I think in that sense you're kind of right.
So if I may, I would like to go back to the consideration whether or not it's good to have practical experience in building a software system to be a good architect. So, maybe I have a controversial question. So when we teach software engineering and when we need to define and motivate software engineering, right, we often use the analogy with other engineering fields, such as construction engineering and so on. And then we do the same when we want to express or define or, the concept of software architects, right? But then I want to use this analogy, and I'm asking, do you think that an architect like, I don't know, Renzo Piano that built the auditorium that we used yesterday, has an experience as a bricklayer or a plumber, or actually building concretely something like a building or anything at all?
So, is the question? I guess the question is, if we're making parallels to the other disciplines, some architects build design visionary systems, but they may not have done some of the skills.
Maybe you need definitely expertise to be an experience to be a good software architect, but do you need expertise in actually building, being a programmer? So if we use the same analogy with
I think it's a rhetorical question.
I mean, I think you do need to understand the materials you're working with, just as if you're architecting a building, you need to understand what you can do with concrete versus brick. It doesn't mean you have to be a bricklayer necessarily. But I think something that I find instructive when I think about, well, what is an architecture mindset? And how does that differ from programming? And it seems to me, at a very rough and abstract way of looking at programming, is largely about functionality. How do you compute some particular value? Whereas architecting is about making trade-offs of other qualities, security, performance, reliability. And it's that changing perspective where suddenly the functionality is trivial. Assume it's trivial. Anyone can do that. The hard thing is getting the system to have the right performance or scalability or whatever ilities you have at hand. And it's that shifting mindset from how do I make it compute something to how do I make it have systemic properties that becomes the challenge. And it's a different way of thinking than programmers are taught. They may have to worry about algorithmic performance a little bit, but they're not thinking at the system level overall quality attributes. And to me, that's the big change that you have to get students to understand in a course like that.
Yeah, and that builds naturally into what you've all been saying about needing interpersonal skills, because as you start to think systemically, like David was saying, you need to talk across teams, you need to talk across people. You're not just sat there with your IDE getting the fastest, best algorithm ever, that you don't have to talk to anybody. And so I think that's exactly right. David hit the nail on the head there.
So I think you pose a very, very deep question, in fact, because especially nowadays that software is everywhere, and by the way, we changed last year our software architecture course, we call it digital architecture, because the boundary between software and the physical and the other things is, I don't think we do software architecture anymore. What I wanted to say is that because of the pervasiveness of digital nowadays, I think more and more we have teams in practice of people that maybe not all of them need practical experience or need to master the technology, maybe part of them, but then you have interdisciplinary and multidisciplinary teams that maybe some of the people in the teams are more theoreticians or researchers, because I can think of a colleague that is an expert in system thinking. Thinking systemically is not easy. And then you have to bring with you, next to architecture and system building, all types of longer-term implications on what you are building. Are we building a society which is including all the citizens? These type of things. And maybe some people are more experienced than others, some others bring other competencies.
But before that, I want to make a comment. All the things that we hear about other engineering disciplines are not always correct. Architects, in fact, are made to lay brick and do concrete so that they understand the difference between materials. As David said, they're not maybe experts, but you need to understand the technologies and materials to be able to do the trade-off. So I think those analogies sometimes get lost.
Yeah, hello, one question. I think in Italy, in general, if we look at master programs in software engineering, we have two big competitors. One is industry, okay? And indeed, we are trying to collaborate them, to bring them, to make things where people can work and stay at master level, but it's still very slowly in our culture moving. And the other competitor are the hype topics, cybersecurity and AI. Okay, And this means that I think it's not only a matter on how to teach, but how also to get the resources, especially master level, and the numerosity and the quality to create next generation of software engineers that also know about AI and also know about data. Because I don't know in your case, that's my question. In our case, I feel that we are shrinking. Okay, and for example, what we are doing, we have an international program. One is with Patricia and others on sustainable and software engineering. Another international European master program that brings together data science, software engineering, and ML. Okay, so in this way, we are getting still good numbers in international students. But if I look at the head of the study program in computer science here, not having those two programs today, having only the local traditional advanced software engineering with the experts that you may know, I mean, are in this room, then the numbers will be kind of, potentially very small. So I don't know what's going on in your countries, universities.
So maybe the only education opportunity will be the undergrads, and everything is education on the job. David.
We did a study recently to try to figure out statistically what's a return on investment for doing a software engineering master's program. And on the surface of it, it didn't look very compelling because people with a good bachelor's degree in computer science were getting the same jobs and the same pay, maybe a little less, but not significantly. And so what we discovered in looking at that was, the important thing was the velocity of advancement. So we did a lot of post-graduation evaluation, and we discovered that people with a master's in software engineering progressed almost 3 times as fast to leadership positions. And we're making much, much more within 3 years than their counterparts who didn't have that. There was a lot of work to do that, actually, to track all of these trajectories there. But recently we have a paper on that if you're interested in that.
I couldn't agree more. That's absolutely also our experience. I mean, you need to see also that you need to have this kind of lifelong learning perspective as an architect. Yeah, so the technical expertise of today will not be the technical expertise of tomorrow. You mentioned, Henry, the ML things, data science. Last ICSA, where we met in person, that was not such a big topic like it is now. No? And if we meet in 3 years again, ML will be all over the place, and people have incorporated it, and there will be a new kid on the block that we all need to learn and we are excited about. Maybe it's 5 years from now. That's our reality. No? And the people who are ready to always extend their technical expertise, they are also better at architecting, I guess. No? Who stuck in their old ways will not be the best architects, I think.
I also agree. We observe the same in the Netherlands, as David was saying. I would also, so we get a lot of students that are actually IT professionals that didn't go for the master before, and then they come back and next to their family and profession, they go further with the study. The same for PhD. I think, at least in the Netherlands, the PhD also gives a further push also in the career and in the competencies, the way of thinking. And the last comment for me is that I don't think that AI or security is any competition. This is the wrong mindset. What I see is that they are very popular, very necessary. But for instance, at least my AI colleagues, they are not able to do software engineering. The security and cybersecurity colleagues either. So I go back to the multidisciplinarity, which gives the real competencies. So that is the extra competence that makes a difference.
I wanted to add a comment along those same lines, especially what Uwe said. Jim Copleen and I wrote up some patterns of organizations and included one in there called gatekeeper. And the gatekeeper is the role, it's the person who is always looking out ahead and having a view for what is the next technology, what is the next big thing, how can we improve better than what we are doing now. An architect can fill that role, doesn't have to, but there's a pretty good match between architectural skills and the skills of a gatekeeper, to be one who knows how to look for the next technology, knows how to understand how to put all those pieces together and advance the state of the practice within one's company.
Yeah, no, just one final comment about you, Patricia. The point is that I agree with you, but what is happening is that the bachelor students then move to other directions. So that's my point, that what's happening in Italy. So instead of going a master program in certain disciplines, they move to other master programs. Okay. Just to conclude, I think that's something that I think that we did well. And thinking now, we decided as a group in software engineering, we were tempted to change the name at master level. Now we organize also a specialization at bachelor. We were discussing a lot, but then we decided to keep software engineering, maybe with some adjective or some other advanced whatever, but we decided as a group to call it software engineering, because I had instead the understanding, and in some other universities, they are renaming, just following the trend, being scared that software engineering is not going to be popular and attractive. So that's just a decision that we made that I think I'm proud of it.
Yeah. And I think this applies to many as cybersecurity engineering, AI engineering. There's all these tagged on engineering, which in the background it's software engineering with that focus, and it kind of creates that confusion and probably masks the fundamental skills that you need to be taught. And I think changing the software architecture to digital architecture, there's the changing needs of the domain as well, that you need to be aware of the hardware and the data and other aspects, but I think the challenges don't go away easily. Is that any other hands? So maybe let's switch, and some of the folks in the industry might also have an impact on it. What are some of the expectations of industry from software architects, and are we meeting those expectations while we're dwelling with some of these challenges on the educational side? Yes? No? Lydia? Any feedback? Now, how about from the audience? Go ahead.
As I'm working for 30 years now in the industry, I guess I can answer what we expect from an architect. More or less, it's taking responsibility. So yes, you need the personal skills to take responsibility, because beside the project manager, which does it on the management side, the architect is the second really responsible key person, or the key figure in a team. So the first one is you have to take this responsibility and play it really. The second one is, yes, you need to take responsibility and do your job as an architect, so create your walking skeleton, get the things done. But for most importantly, for me it is, you have to be a finisher. So in a software engineering project, you cannot tell, okay, as a team, here, I agree with a lot of things, but not with the team approach. Software engineering is a team approach. Architecture is not. If you start putting architecture tasks on a lot of people, at the end you will have no single person you can take into accountable and say, okay, what is happening? So from my perspective in the industry, we ensure that even we have cross-disciplinary teams, all this stuff, and agile, it's all fine, but when it comes to architecture, it has to be a single person. And this person has to be responsible. So, yes, we expect that people take this responsibility and this exposed role and play really this, and finishing the project. So a lot of hurdles exist in practice, a lot of technical problems. But yes, it's happening all the time. For a software engineer, it can be okay as part of a team say, okay, I cannot really figure out what now to do. The architect is the one who at the end has to help, not as a single person together with the team, but he has to lead the team to finish the project at the end.
So if I summarize, do you have the guts to make the decisions and stand behind them?
So I'm not sure I agree. I actually used to have exactly that reasoning, because I saw that if projects where not one single person would take the ownership of the really big concerns, they would tend to have more trouble. But I have also seen a lot of counterexamples where organizations didn't even have a role they called architect, but were still doing architecture pretty well. And this was because they were aware of the responsibilities that we together identify as architecture, but they had just divided them in a different way. And if you do that, then you can still have that ownership. I think ownership is the key. I agree with that. Some people call it leadership. Some people say architecture is about content leadership. But I think ownership, being focused on delivery, on delivering the end result, closing the deal. Yeah, that's absolutely. The projects that go wrong are usually for lack of ownership, and either on the technical side, but more often even on the business side.
Maybe actually it's about leadership or ownership is very much connected to culture, because it comes to my mind when you were commenting, an alumnus of mine that is an architect, and he worked in Germany, and then he moved, he's Dutch, he worked in Germany, and then he moved to Sweden, and he was telling me about how decisions and the dynamics totally different, and his own expectations were of one culture and then is another. So both local culture and organizational culture determine a lot what is the dynamics of decision making in architecting.
My context was Germany.
That explains.
Thank you very much for this beautiful discussion. I would like to turn the page a little bit, and I would like to ask, do you see that there is a place for values in teaching software architecture? And if yes, then where and how? Thank you.
Now it's time for Patricia to dance.
Oh yeah. Thank you for the question.
We did not pay you.
No, actually, there is a PhD student of mine here. She works on ethics. No, she is a she, so another one. No, not her, another one. No, this is a big thing. And for instance, we learned last year from a bunch of architects from CGI that work for many different customers that values are an issue. And they are another implicit thing that, so story short, when we design and implement architecture and systems, we, as developers and architects, we embed implicitly or explicitly our own values in the systems that we deliver. And this is wrong. Simply because, again, extreme digitalization, then these systems are being used eventually by other people and users or customers, and they have different values. And then this also potentially determines also the chunk of the markers that I, as an organization, can achieve, but also if I go against these values, so creating conflicts and et cetera, et cetera. So I think that values is a different type of concern, equally, if not even more important than traditional quality concerns that we are more used to. And of course, this is part of the social sustainability of systems, so I had to say that.
Yeah, and just want to point out that this PhD student that Patricia is referring to co-authored the paper with the two of us, I think. Where's Razia?
Yes,
anyway,
and she's presenting tomorrow.
She's presenting tomorrow morning,
All right,
yeah.
enough of
And so
Any other perspectives on the values question? Or David, you? No? Whether you jump onto a technology or whether you wait and do the trade-off is also technical values and how you do the trade-offs aspect. So I think that comes implicit with some of the perspectives.
by the way, one of the techniques that we have found to be useful in including the values talking about ethical or societal values in the design process, the architectural design process, is the utility tree that we found in the SEI's Software Architecture in Practice book. The utility tree actually is very well suited to, you can almost seamlessly insert the ethical values there next to other quality attributes. Maybe you need an extra layer of abstraction, but we've been successful in applying that.
And in fact, some of the experiences that is encapsulated in those, well, we don't say a single architect, but we do say a concentrated small group of individuals responsible of the decisions. So I would agree with that as well. Right. Any other questions from the audience?
Yeah.
Okay.
Sorry, the suspense has been building for 5 minutes on this question, so I have to, yeah.
Where is it coming from? From online?
No, I'm here. Look, even more suspense. Yeah, I had a more basic question. Maybe we danced around the topic, but it was about software project failure, right? So I think around 50 years ago, we had this big issue about projects failing, and then we've now invented this entire discipline, and they still fail, right? So, so I was wondering, what do you see as your role in this, as educating the people who make software that fails?
Okay, you've hit one of my hobby horses now. Yeah, software systems fail, but 99.999% of the time they don't. Pick up your phone, you can do amazing things. This world is driven by software. I'm flying on a plane tomorrow. It's going to get me back to Seattle, almost certainly. And it's going to be software that gets me there. So we do screw up. Everyone screws up. But as a whole, this industry is superb at building stuff. And it might not be built the best quality, and it might have technical debt, and it probably could be done better. But in reality, we are bloody good at what we do. And so let's not sit here and say, oh, but there was a disaster. Amazon's S3 went down. Yeah, well, it's actually statistically meant to go down for about 30 minutes every 6 or 7 years. And it does, you know, but that's pretty darn good. So sorry, off horse now.
Oh, you just pour water onto the fire. But if you're really interested, as of next issue, IEEE Software will actually start a column called Failure Mode by a Netflix software engineer architect, Lauren Hofstern. So we'll feature some of those, but I do agree with, I think, Ian. Yes, there are lots of failures. I love technical debt and all that research and architecture, but I think we do not bad as well, but we could improve. That's why we're having these conversations. Right. Other questions? Well, I hope you do appreciate the collective level of experience that's here in this room, and I thank for every single panelist. And I didn't mean you jumped jobs, Ian. I meant you bring a lot of expertise from different perspectives. And so, first of all, thanks to them. And I would like to give each of them any closing thoughts, especially in terms of maybe what is the role of some of the work we do of software architecture? Can we maybe look more forward and reduce industry's reliance on software architects and some of these skills? And is there room for that? Or any other closing thoughts that you have in terms of educating the next generation software architects and why we should keep coming to these conferences to share our experiences? And you can start in any order. All right?
Yeah, so my closing thoughts would be with, looking towards the future. We saw, of course, this morning how Tatiana looked at the future, which was full of artificial intelligence. And I think the key thing here is the human values. And I really like the question about that, of course. And I think that not many software engineers, coders, developers, and architects are aware of the impact of the decisions that they make. Grady Butch has a tweet that he puts out, I think, a few times every year, where he says, kind of, maybe exaggerated, but he says every line of code represents an ethical or moral decision, right? And maybe that's a little bit over the top, but it does get the discussion going every time again. And I think that's the human side of it is where we should look in the future.
Yeah, of course I have to mention the sustainability impact, but I think a very important aspect is time. So you mentioned, you two in the previous session, the long-term versus the short-term vision and reflection. I think embedding time and representing time in software architecture and interpreting, for instance, the monitoring, the impact on quality requirements on time is something that is really, really necessary.
Yeah, maybe I can relate again to what Ian said last. Yes, so I think if you see the complexity of the software stacks we are now dealing with today, in contrast to previous things. So, for instance, my main area is distributed software systems, and when I started, things like COBOL, transaction services, and so on were
book on that.
started in research now, were on vogue, and actually when the COBOL standard came out, everybody was thinking, okay, now the distributed systems problem is solved. And see how far we got. Now every layman actually can, let's say, put on a service onto AWS, scale it to the population of this planet with zero effort. That's actually quite a treat, no? And I think you in order to make the new technologies and all these things that are coming up, the new concepts, the new responsibilities all work, you actually need even more architecture, not less usually.
I'll come back to the main point I was trying to make, which I think architecture is something many different roles of people need to understand. And so I think we have to stop thinking about the course in software architecture. There may still be one, but we need to start thinking about how do we make that field pervasive across all of the software engineering activities that we teach. So programmers are learning about some aspects of architecture even as they're programming. Managers, product managers are learning about it. And I think we've tried to package it up in a nice, tidy chunk here, but we do a disservice, really, because it needs to be much broader.
Okay, I'll probably surprise you all with this one, but I'd love to see much more diversity in the field. One of my proudest achievements of the last 8 years is the program that I built in Seattle has 53% women. So you walk into our campus and people think, this is a computer science campus, what's going wrong? You know, there's not enough men here. The reason we've done that is that we've managed to create a program where we can take people who are educated in different disciplines, rapidly assimilate them into computer science and then thrust them into the master's program successfully. And because of that, we can bring in a much more diverse set of students. And they bring different skills as well. And as Patricia said, you know, we embody our own selves in our decisions, and then hence the more diverse of a profession we have, then the more diverse thinking we have in the profession. And I think it's really, really important. Seattle still has, I think the latest number was 78% of the engineers in Seattle are male. And it's only changed like 2 or 3% since I've been there. But we're chipping away at it, and I hope the whole industry takes it really seriously. So I hope in 5 years' time when I come here, it might look different out there. Thank you.
Well, thank you all. I hope you learned something from the conversation. I certainly took a couple takeaways. First of all, one is the software architect as a career path versus software architecture as a skill set that every single software engineer or anybody who's part of the software engineering team should embody. And I think there's a lot of deep thought there. Obviously, there's no one who's going to negate diversity. We all would like more diversity in thought, in global representation, in gender, and in any other field. But kudos to Seattle and Northeastern and Ian's program. And with that, thanks a lot for everybody staying here, and thanks a lot for the wonderful conversation. Talk to you later.
Okay,
Okay, then welcome to the next session, the last session of today on architecture and industrial practice. So we're still on the very industry-related day today, and that we'll also see in this session. We have 2 software architecture and practice papers, 1 paper from the technical track, where you see the slides already up here, and then also 2 journal first papers, all related to a lot to insights from industry. So I think this will really be an interesting session, and I'm looking forward also to interesting discussion here. Yeah, let me actually, without further ado, hand over to the first speakers. And you really chose a nice title for the, I think you can use either one if you like. You really have a nice title for the presentation, so I think we are all now looking forward what's behind.
So thank you very much. Yeah, the beauty of software architecture. My name is Ralf Engelschal, and later Celine Aldenhoven will take over for the second part. I will introduce you to this topic, yeah, beauty, a little bit unusual perhaps from the topic, and yeah, why? Because beauty fascinates more or less throughout the centuries, and even in many disciplines, etc., and even the greatest thinkers of all times. Be it people like Leonardo da Vinci, or even in the software architecture field, perhaps Vitruvius and others. So this is really a topic lots of people, even outside of software architecture, are fascinated with. And for me at the industry, I have 40 people working for me in the software industry, and they are most of the time in architecture assignments, or even have even the dedicated architecture role. And they talk about things like, is it an adequate solution or a beautiful solution? So all the time I had those 2 topics, adequacy and beauty, in front of me. So as a result, I first in a keynote on a German software engineering conference, 2001, I raised this topic for me about beauty and, well, inadequacy of software architecture at the same time. And the interesting point, perhaps, or at least for me, it is even a paradox, is that when it comes to software engineering, and especially to software architecture, in the definitions you see on the left side, a possible definition of software architecture, there's no single indication of things like adequacy or beauty. But if you go into practice and talk to the people who actually have assigned the role of architect, they raise things like, yeah, this is an adequate solution or a beautiful solution. So this was really, for me, an interesting point. Why is this discrepancy, or this paradox, that the definitions all the time talk about structures, patterns, all those important things, but the people talk about other things. So as a result, I first supervised at the Technical University of Munich a master thesis on adequacy, on the first part. And you see on the right side a little bit of a particular model how one can approach adequacy. It doesn't matter currently here, just to give you this context. So we first investigated on adequacy, and in this investigation we found that adequacy on one side, you see it on the left side, is something like a measure how suitable something is in an environment, fulfills the imposed functional and qualitative requirements, so this fitness for purpose, from the individual and subjective perspective of a person. And during this investigation, the beauty side all the time came also, were raised by the interviewed participants. And at the end, we also, as a side effect, resulted in a possible definition of beauty. You see on the right side. Beauty, the perception, how simple, elegant, natural, secure, and evident, or as an abbreviation perhaps, sense, something is from the evolutionary and cultural perspective of a person. Yeah, 2 different terms, but for most of the people, they even in practice use them interchangeably. So this was really interesting for me, and especially when it comes to the implications between the 2, because sometimes people switch from one side to the other, not in all possibilities. You see, beauty usually for most people in the industry implies adequacy. So if they have a beautiful solution, it is also an adequate solution, but it doesn't work on the other sides. For instance, yeah, no adequacy implies no beauty, but adequacy does not usually imply beauty. So there's a lot of adequate solutions in practice which are not beautiful. So for me, this was really interesting, and as a result, when Celine Aldenhoven came to me in the industry and did her internship during her software engineering study, I gave her a few research questions and Celine, please help me. We really have to dig a little bit deeper on this beauty side, because I guess adequacy we already understood, at least to an extent where I was satisfied myself, but
the beauty side is still confusing, especially because people are interchangeable. What does people really mean when they say this is a beautiful architecture? So we had in Celine's research two particular questions. One was on the definition. Is there a shared understanding of beauty among the practitioners, which later were interviewed by Celine? Then the relevance part, why is beauty important? Because, well, just because people talk about it, yeah, it can be an indication it is of importance to them. And how does influence us in our software engineering community? On the third one was the methods, how can we create beautiful software? So on a practical side, because if it is important, okay, let's do it, but how? And finally, because I've also a lecture assignment on software engineering and software architecture at Technical University of Munich, it was also the side, what is the best way to teach all those concepts, if they are important, to the people? Yeah, so at this point I will give over to Celine, who did actually this investigation. She interviewed lots of people inside the industry at MSG Systems, where I'm working. It's a software company with 10,000 people, and even outside in the open source community and many more. And the findings on this, she will present us. Please.
All right, so thank you for joining our presentation. Let's just dive into the results, as we do not have much time, but feel free to read our paper then afterwards. All right, so for the first question, are there any similarities what practitioners view as beautiful? Because some people say beauty is a very subjective field, many people have different insights, but we actually found that there is a common ground in what is perceived as beautiful in terms of software architecture by practitioners. So we came up with a definition. Practitioners view software architecture as beautiful when it reduces their effort to work with it. So a pretty functional definition, right? What it means is that if software architecture manages to enable developers and all the other practitioners who work with it to freely integrate new features, adapt it to new things that might arise, this architecture is perceived as beautiful. While in return, when software architecture does not really enable practitioners because you might have to bootstrap solutions or have a lot of bug fixes because different things just do not work correctly with that architecture, might be too complex to understand, etc., it's not perceived as beautiful. So now for the second question, our most important findings on that one. Why are we even talking about this, like right here? Why is it even important? Why do we have to discuss beauty in software architecture? So here are map 4 of our most important findings. First, actually practitioners who work with it for a long time, so practitioners who are in the industry for a long time, definitely have this sense of beautiful software architectures. And they even perceive it as beautiful somehow, but before our research, they were not really able to describe this feeling, why some architectures are perceived as more beautiful, why not. And they definitely indicated in our survey that it is sometimes even perceived as more beautiful to them than the beauty in their environment. Then we found that it has actually mental health implications on the software developers and other people who are working with software architecture when it comes to the beauty. So beautiful software architecture actually motivates software developers and like other software architects, general practitioners who work with it. It makes the mood better, they have more energy, they like working on that project more, which is obviously something very important to consider in mid to long-term projects, because that can determine the success of the project. And on the other hand, ugly software architecture makes them frustrated. They do not work with it anymore. And yeah, it's a pretty bad job then. So beauty seems to be important, right? And what I've mentioned before, we actually investigated further, so it really does motivate them. So beauty in software architecture does motivate developers to work on that project, and in return it really demotivates them very much if it's not there. So additionally, another point why it should be considered at least in mid to long-term projects when we want to have successful projects. And lastly, we have found that there are many precautions if it comes to software with beautiful architecture. So if people have only little time to assess like a software system in a whole, they have a lot of precautions when it comes to the quality of the software system in general, when they only have time to like look at the architecture and like small features. So this is something important also to have in mind when you develop software and deliver it to a customer, who then in return will develop the software further for assessment. So now, let me quickly, very briefly, introduce you to 7 points that you should master when it comes to how to create beautiful software architecture. What do we need to do? What do we need to learn? So first, we need to be able, as software architects, to abstract. And this is something a key feature. If you're not able to abstract correctly, probably won't result in a beautiful architecture. Then, throughout the project, it's very important to focus on holistic consistency, because in a lot of software projects, at first the architecture might be great, like beautiful even, but if the project goes over a longer period of time, a lot of fixes are made, like new things come to the architecture, old things are just not being further developed, and it is very important to keep the architecture beautiful over time, and therefore to focus on holistic consistency. Then, requirements engineering is actually very key to create a beautiful software architecture in the first place. So if you do not understand the solution or the problem domain, you cannot be able to create an adequate or even beautiful solution to it, right? Then, we need to be able to simplify. If you look at our definition again, it reduces the effort to work with it, so it's beautiful. Well, if it's not simple for developers and other people who work with it, and it cannot be understood very easily because the architecture might be too complex and all over the place, then, well, it's not very easy to work with it. And, of course, something obvious, we always have to plan for future change, but when we are in the practice field, somehow, sometimes, we're like in the right now, like work on the project right now. We do sometimes miss to think about possible futures, and requirements engineering can actually also help to have that in mind all the time. And beautiful software architectures have to be iterated. So you have to come and revisit an architecture overall all the time, not just make minor fixes, because then you won't be able to keep up with changes. And last of all, most importantly, we have to be able to be creative. Software architecture is not something that you can like teach like a formula. If you have that problem, solve it like that. We have some tools and like patterns or modeling techniques, and we have to use them creatively, and every time is new. Like every problem is a new one, and we have to be able to creatively adapt our solutions to the problems. So lastly, beauty can be taught, I can tell you that, but how? So, as I just told you, there are some active methodologies that we can actually teach in a classroom, like patterns, like UML modeling. Like if you don't know these fundamentals, it's gonna be pretty hard, but you can teach them and you can actively teach them. But the most important part is passive. But how can we most effectively teach these experiences, so to say? So well, you have to work in extremes. If you're able to search for projects and you can decide on which projects to work on, I recommend that you work on projects with very beautiful software architecture and ones with very ugly ones. So you make the most important experiences early on in your career and then have better learning outcomes faster. And the last one is the buddy program, which would be too long to describe here, but we have described it in our paper, if you want to read it. So just briefly let me catch up. What did we see so far? I know it was quite quick, we did research on that, but we have actually looked into the definition of beauty, like what's the common ground among practitioners when it comes to beauty in software architecture. Then we have discussed why it is so relevant to talk about this subject. And we have revisited some methods that you can use or that you can practice and teach yourself to be able to create beautiful software architecture. And lastly, we have talked about how we can actually teach it. Yeah, and that was our presentation. If you want to keep in touch, here's some contact details. Thank you so much for everyone who listened, and we're very excited to hear your questions now.
Yeah, thank you very much. So do we have questions in the room? Yes, please, down there, or even two.
Thank you. Very interesting talk. I'm coming from computational creativity field, and this aesthetics and these kinds of things are very close to my heart. What you described as the definition of beauty, it sounded to me that it's more like usefulness. Was that definition coming from the actual architects, coming from the field, or how did you come up with this definition?
So we've actually been interviewing over 65 practitioners, and then we've done grounded theory coding to identify what the similarities are, because of course there are different opinions on beauty in software architecture, but like that was the definition of the common ground. And yeah, it is kind of similar to usefulness, but I would say that usefulness also describes like how useful is the architecture, and our definition is more like how does the architecture enable practitioners to do their job, like a little. But like, yeah, I get, like it's a very functional description, but in the paper, like for instance, Immanuel Kant has a very non-functional description of beauty, and in our paper we also discussed like the philosophic approaches on that definition, and to come up with the several research questions, we actually had more. We just published the most important ones. We read articles from plastic surgeons, what's beauty, from like philosophers, etc.
That actually comes to my, maybe not a question, but a suggestion that maybe you want to look, for example, how mathematicians look at the problem solving and the elegance of those proofs and so forth, that I think those would be closer than plastic surgery and whatnot.
We also looked at like classic house architects, how they describe how to like do architecture like for houses in a beautiful way, and like many different approaches. So just like
okay.
People, but of course, yeah. Very
Thank you.
nice insight.
But especially you see that it has nothing to do with structure and patterns or anything like this. This was the most important, our understanding, that while in classical teaching all other things are taught to the people, while what they perceive as beautiful and important to them is completely different.
So I have a follow-up question. So thank you for the presentation. It was really, really beautiful. Here. So following this last thought, I think we all can agree that beauty is something that has changed over time. So do you envision the beautifulness of software architecture being also an evolutionary concept? Something that will change in a few years, or that maybe has changed and it wasn't like that, like, I don't know, 20 years ago?
That is actually a very, very interesting question. in our further research section that we could do, or you could maybe do, we actually mentioned that because it's just that software engineering or like software architecting and computer science in general is not a too old field, so it's very hard to predict. But I'm not sure. Like since our definition is very like summarizing like the common ground, I'd say that it probably will stay the same. But that's a very, very interesting topic to further investigate on, definitely.
So we have something to do in 20 years. Do a re-investigation and then we will see.
Yeah, so we'll have time for 2 more questions and then we'll have to move on.
I think there is a question online from Eduardo Guerra, which raised his hand. So, Eduardo, if you are listening, you can do the question.
Can you listen to me?
Yes.
Yes, we hear you.
No, I raised my hand because the audio from the chair and from who is doing the question is great, but not from the microphone from the presenters. So that's just this feedback.
Is it better now? Can you try again?
Yes, yes.
Okay, I'm so sorry for that.
No, not so I can't hear you.
You cannot. Then we'll use this microphone for the next talk. But okay, thanks.
Yes, perfect. That will be great. Thank you very much.
Yeah. Okay, yeah, first, thank you very much for the great talk. I would be interested in if you considered the role of the documentation of the software architecture in your research, since I think this is a bidirectional connection between software architecture and its documentation, because the software architecture can be as beautiful as it can be, but then on the other side, when the documentation of it is pretty shitty, then the software architecture is also not that good in my opinion. But on the other side, when the software architecture is maybe a little complex and huge and whatever, but the documentation is super good and beautiful, in your words, it might be the case that it's also very useful for all the software engineers and software architects then in general, and the software architecture which is huge and stuff could then be also beautiful because of its documentation. What is your opinion on that?
That's a very, very good point. There have been some little researchers just writing books about beauty of software architecture, and they have actually included the views on software architecture into that beauty definition. And we just wanted to explore what practitioners think, and in our findings, not directly, so practitioners not directly include that into beautifulness. We elaborated on that, and we thought that it's probably because if you're okay, let's compare it to normal classical architecture. You have a house and you can see directly the architecture. In software architecture, that's not the case. You have just different models, like flowcharts, etc., that model one and the same architecture from different viewpoints, and you can make them very beautiful, very understandable, right? But actually, in our investigation for practitioners, it's more how you're working with the code and how you're working with the architecture in general. That's perceived as beautiful, and they have their own imagination of the architecture as itself abstracted from its presentations. But yeah, you can definitely elaborate on that further, yeah.
So in practice, yes, there is a connection between those things, but not when it comes to the beauty aspect. Yeah. So you're right that the connection exists, but not on the beauty aspect.
Okay. So while the next question,
thank you very much.
Let us get the presentation ready for the last question.
Which one?
Okay. Yes.
Okay. Thank you for the beautiful presentation. So I did some work with evaluation methods for software architecture. So where this method talk about if you want to evaluate a software architecture, first you need to like if you think about SAM, scenario-based architectural evaluation method, you need to work with scenarios different, and these scenarios come from different kinds of stakeholders based on their uses, and then you have to extract the quality attributes from the scenarios. So quality attributes could be ease of use, performance, security, and the evaluation methods actually say that you have to map your software architecture with the quality attributes. Then you have to check like whether your software architecture could satisfy those. If they could, then it's a good architecture. Now, I didn't hear the term beautiful architecture before, so it's the terminology I'm hearing first from you. So how you actually map these evaluation methods concepts with your beautiful architecture concepts? Yeah.
I guess it has to do with adequacy. So
I guess the most important point is you have seen from my part that there's adequacy versus beauty. And the interesting point is when it comes to the qualities you are talking about, you want to meet with the architecture, people in practice all the time use exactly the adequacy part. Not the beauty part, interesting. So when it comes to the beauty, it was what you have seen, whether it helps them to get their job better done. And when it comes to the qualities, this is actually coined more adequacy. And this is used by practitioners also, but usually they do intermix adequacy and beauty sometimes, but not when it comes to the qualities. Then they are more or less sure this is an adequate solution because it meets the particular requirements.
Does that satisfy your question, or?
I'll read your paper more, thank you.
Okay.
There will be time maybe for discussion.
Okay. For more questions, feel free to contact us and we'll answer the rest of the questions. Thank you so much.
Thank you very much.
Okay, let's thank the speakers again. Thanks a lot. Okay, and now I'll hand you the microphones. We have Hanan here telling us about architecture tactics. Let's use this one because it's better to hear for the remote participants, it seems. Yeah. It's okay?
Oh, yes, thanks. Good afternoon, and thanks for being here with us. I'll be presenting this work entitled Architectural Tactics in Software Architecture. It had a temporary working name. There was like 2 decades of architectural tactics, but in this being the proper title. The authors are Gaston Marquez, Rick Katzman, and myself, who will be presenting. And this is... There we go. So this is a journal first, and that's the abstract title and so on. There we go. Thank you very much. So what are tactics? Which is essentially what we look about. This is a well-known abstraction from our disciplines, probably one of the key abstractions that we have contributed as a discipline. Key design decisions that influence the control of a quality attribute. This is a textbook definition. Influences the system's response to a specific stimulus, and the stimuli can be categorized and so on. They arise from collective experience. In practice, they are gathered and recognized from actual experience through several techniques. We'll take a look at them. And of course, provide a foundation of knowledge. It's one of the most interesting abstractions for reuse of knowledge, just like our patterns and styles and so on. So, in essence, it's a strategy to represent fundamental design decisions to achieve quality attributes. So far, so good. But architectural tactics as a concept have a history, which is something that if we just pick up the 4th edition of the BCK book, we won't realize. There are definitions that are more than 20 years old from some of the same people. Design decisions that help to achieve a specific QA response, okay. Means of satisfying a QA response, okay. Pretty much the same people, 2003. It's a technical report. Identify and coding underlying primitive of patterns to solve weight. Wait. So we were just talking about qualities and decisions, and suddenly we're talking about patterns. We get back to the first edition of Bas Clement-Kasman. We get to architectural building blocks. Latest edition, design decisions that influence the control of a QA response. So there are like several wordings or phrasing, and there are two main emphases. One, design decisions. Two, they are somehow related to architectural patterns. So if there is a history, it deserves to be explored and to see how it has impacted our work. This is a well-known example taken from, I think it's the first edition, availability tactics. There are 4 kinds of decisions like this the architect has to take: how to detect a fault, how to resist it, how to recover from it, and how to prevent future faults. And there are 3 standard ways of detecting a fault, right? Ping, heartbeat, and exception, and so on. So this is fairly standard as of 2003. A little is 2013, which is pretty much the same at some level. Just to make sure, yeah, for the ping heart, yeah. So, okay, so there is a variation. And there is much more than that. This is only availability. How has it changed a long time? Well, we have a beautiful problem, which is a really beautiful problem, and is that there is a lot of work done on tactics. And I think that nobody knows it all. Or maybe Rick. Probably Rick does, but he's not here. So the definition has evolved to address a lot of concerns. And it deserves to be explored because there are actually hundreds, closer to 1,000 than to 100, of peer-reviewed, only peer-reviewed. We're not even talking about great literature. So there is a wider use of tactics that has led, and this is the actual problem, to a lack of explicit knowledge of how tactics are identified. There are lots of work that talk about tactics, but there is no, as we will see, not clear consensus what they are and how they are recognized in the wild and documented and so on. So this limits, of course, the systematic replication. In other words, one of our holy grails. How do we systematically reuse knowledge to build complex systems? So to address this, we did what we always do, I guess, systematic literature review and so on, to get to know the state of the art, objectives, identify, analyze, evaluate, and body of knowledge, etc. We formulated 5 research questions. Well, if you've done this, you know we formulated more and then less and then more, but eventually these are the ones that made it. Which QAs have been addressed? I mean, what are they used for? How are they identified, recognized, described, and how are they categorized? And this was a study, a summary. We identified over 500 studies, selected them with some criteria, almost 80, some snowballing, 15 more. We merged some, we are different format and so on, eventually 12, we got 91. 91 main studies which you can identify in the first annexus of our paper. Demographics, 91 studies, 16 years, pretty much. The initial works are all reports, technical reports. 2003, we get papers and so on. We didn't find papers for 2006 and 2007, curiously. And we get, most of them are on conferences like this. It's not a big surprise at all because computer science moves in conferences, which we know and to big issue. And top one is this conference. So which means that yes, we are in the right place to talk about tactics. Because the other just equally ranked is ICSA, which is in September in Turkey. So we get a lot of work done in conference. How has it evolved in time? It's fairly stable. After a while, 2012, essentially, last decade and so on, fairly stable except this weird year. And you get about 2-3 papers, journal papers and so on conference. Just a fairly, we could say, mature topic. Is it worth to get into it? Well, it looks like this, because Most work, we categorize them by kind of work, kind of contribution. Most of it proposes solutions. Some do evaluation research. We've done some. A few are philosophical. Very few talk about experience or opinion. So there is not much reflection. There is a lot of doing. We are engineers. We are informatics. We build things. And in fact, we propose frameworks, maybe models. And if you're really pressured, you can get one set of guidelines, a couple of tools, and so on. So in practice, literature, despite being a lot, is mostly very applied. What's being most researched? Research question number one, security. Not safety, which is different. Security, and we could argue eventually that if you argue that availability, confidentiality, and so on are security, then you can add more and it continues being security. What are tactics used for? You can see this figure, and essentially for a lot of things, to define general scenarios, to represent test cases, and so on. Many kinds of, this is a figure taken from the paper. And which techniques have been used to identify them? First of all, multifaceted. The original approach, reading a lot of documents, techniques, consensus, and so on. We replicated also in some studies, and it's actually very time-consuming, very powerful, very time-consuming. Text analysis, and there's code analysis. As of lately, there's a lot of code analysis has been popping up. Who's the winner? None of the above. Most studies just say they found tactics. Or at least maybe we're not very good readers. So essentially we were unable to identify in 2/3 of the cases how they came up with those tactics. Key findings then, most common technique analysis. There is some machine learning picking up speed, which is good, I suppose. It's very fashionable. And NLP and so on. Where do they get them from? We get them from standards, expert patterns, source code, 2/3, none of the above. And so in the literature, 2/3, not the same 2/3, we do not know how they were identified. Key findings, I just mentioned them. Mechanisms used to describe, well, they are described with formal languages, a few specific templates, models, yes, winner, none of the above. We get a winner, it's a clear winner, multidimensional winner. So they are described somehow in a very ad hoc manner. So which tactics, taxonomies do we have? Plenty of them, actually. We identify them. This looked like a very bad LDS, latent dependency structure matrix. If there's no way pretty much to sort it nicely, but it just looks all over. And we make an analysis in the paper that this is very hard to get some interesting conclusions out of this. It's very sparse and a lot of none of the above. So what did we find? 3 overall findings beyond the actual research questions and demographics. And I'll go through them. First, there is little rigor in characterizing and defining tactics, which is, by now, I guess it should be obvious. We could identify a single widely used definition. There is a little analysis about the proper, if there is a proper way, of course, of defining tactics, or even whether there is a proper way. And there would be potential to identify, for example, to formulate a theory. And we speculated a little bit of some of that. But none of that is addressed in the existing literature as of the sending of this paper. Second, right now, most work is devoted to source code and application frameworks, to finding tactics in source code, and to, given that you want to use certain tactics, which patterns may help, which frameworks may help you. It's a very hands-on use of tactics. Much more than being used as design decisions, cataloged and represented and with trade-off and so on. Rarely, if ever, are they described in terms of stimuli and answer. And third, there is little evidence of industrial use. Precious little, which to us is an utter surprise, because it seems to be it's a totally useful. This is confession time, right? It's a totally useful abstraction. You categorize. We have made available as a community and discipline. We have made available brilliant ideas from other people, from distributed systems, from security researchers, and so on. We have made them available and categorized, sorted by whether they are decisions to anticipate, resist, react, or prevent a problem, and they have very little use. And it remains to be seen why. Because maybe they are just a bad idea after all. Maybe they are just not useful. Maybe they are just not known. Maybe they are really hard to teach. Maybe they cannot be taught. Well, it's really surprising. This is really surprising. So what do we conclude? First, this is the standard drawing, right, of if you get a stimulus, something comes here, a source of stimulus, for example, a fault, something fails, and there is a response, and you get a response measure. This is from the textbook. The unexpected, for us, totally unexpected, but unavoidable conclusion is that most tactics proposed in the literature do not conform to the original definition at all. It's not like they vaguely, no, they do not conform at all to the original definition in the sense of being design decisions related to achieving a quality attribute. We could speculate this could be an inflation of the term. Yeah, just like in a presentation before, we had this question about refactoring, and some of the refactorings do not conform to what Updike had in mind. Then the words have drifted, and probably the word tactic has drifted. That's something to be studied as well. Future and ongoing work. First, we think this is essential for us to explore barriers to adoption. Why don't they use it? If it's really such a great idea, why don't they use it? And two, there has to be many more tactics. If there is a systematic and elegant way, I don't know if it's beautiful, but it's elegant, way of defining and organizing and systematizing knowledge, then there has to be a better way to discover new ones. And that's it. Thank you.
So do we have some questions in the room for Henan? If not, then let me start with one, and then you can take the second one. You had now several categories or research questions that you looked at here where the result of the paper was it wasn't mentioned, it wasn't described. I was wondering whether maybe there are different types of contribution related to tactics where then maybe some of these things even are not needed, let's say. So if you, for example, mentioned there are approaches for detecting tactics in source code, then probably different things have to be described in the paper than if you have a paper that actually tries to present a new tactic. And for example, one maybe has to be validated, the other one doesn't have to be. So could that be a reason for these, let's say, missing values, that for some types of papers they are not needed? What do you think?
Could be, from a purist perspective, I would say no, they are necessary. So if they are missing, they are missing. Yeah, but in practice, they're not there. So that's why almost always the winner was none of the above. So yes, probably in practice that means that people who are defining or identifying or proposing tactics in certain areas do not feel that they have to provide those kind of elements of knowledge, like practical validation or showing how they were identified or eventual empirical usefulness. So I would relate that back to this original conjecture that probably the term has drifted, and that deserves to be looked by itself, because according to the original definition, they are just missing. They are just incomplete definitions.
Thank you very much for your presentation. When I was looking into the notion of architectural tactics, I noticed that typically it seems like what is called an architectural tactic in the literature, originally when it was proposed, the author of the tactic didn't think about it as a tactic. So things like the availability tactics that you shown, like heartbeat and so on, or like cache-in heartbeat, exceptions, pink, voting. When people who came up with these mechanisms came up with them, they didn't think about it as like architectural tactic. They thought about it as just a solution to some specific problem. And then people who analyze the software architectures and compile the lists of tactics, they identify like certain solutions as architectural tactics. Do you think it may be possible that in practice, people are not as resistant to tactics themselves, but to the concept of architectural tactic, to the label, and people just are not taught this concept, like this abstraction that something like architectural tactic exists, but they still continue to use, like, we know that things like transactions and rollback are used in practice in many cases.
If I can misrepresent your question, then you propose to distinguish with the actual solutions to technological problems to how we deal with them from a software architecture reuse viewpoint, right? And yes, I agree. Definitely the people who propose those techniques and all of the others, they are people who are from different fields, right? So what we have done, our predecessors actually, is just to organize this knowledge around quality attributes, which is a terminology that's proper to us, around them, and picking on the fact that if we buy this formalism of stimuli and response, then organizing about them, around them. So it may well be that this kind of formal thinking, rigorous, not formal, this kind of rigorous thinking about technology design choices may be off-putting, because people, of course, people are still building ping, heartbeat, and exception systems. So it may well be that the taxonomy, the concept of taxonomy is what's interesting, but not the idea, the concept of software architecture tactic. It's possible. But in practice, what we have seen, and we have deployed this in many courses as well, at professional level essentially, when they see this, they like it. When professionals, they see they like it, but even so, they don't use it, not too much. So there is, even if one could say, well, maybe yes, they don't like the rigorous approach of that stimuli, blah, blah, but they will take home their trees, right, and they will put this in their wall, and they don't. And we think that really deserves, which is the second question. I hope I answered two questions.
Yeah, thank you. Thank you very much.
Okay, then let's have another question while we prepare already the next talk, if there is a last one. I have one. But for that, I'll take the microphone. Could you, a brief one, could you characterize, so you mentioned that tactics and patterns are very related. Maybe the other question, how would you characterize the difference? So what's the difference of a pattern and a tactic in your opinion? Is one a super class of the other?
No. Ah, great. Great question. Thank you. I should have planted that question. Well, one of the original reasons, original mechanisms to identify, and the definition that I showed for tactics was like elements of a pattern. So there is a difference even there. But what would be, in simple terms, a difference? A pattern is a heuristic. When, how, and whether to use certain solution to address a recurrent problem. A tactic is one of the 3 or 4 or 12 standard ways of identifying, reacting, or recovering from a certain problem. Now, we could write a pattern, that's a conjecture. We haven't published it yet, but it's a conjecture. We can probably write a pattern for every single tactic, and maybe more than one. But I don't think it has been done at the design level. But for an architecture pattern, they would probably express, they are, and there's work on that, they are expressed in terms of tactics. So it would be like components, elements within. They're not really subclasses, but elements. Yeah.
Thank you.
Hope I answered.
Okay, let me hand over. So now we have 2 software architecture and practice papers, and I'm looking forward to that.
Thank you very much. Before I begin with my presentation, I would like to comment on what the last answer was to your query of the difference between pattern and tactics. To my knowledge, I think the tactics are, they augment a pattern. So pattern can be used, for example, modularity pattern. If we say it can be used for modular, to enhance modularity, adaptability, reusability, so to say. But tactics are more like, what are the tactics to enhance modularity itself? So adaptability itself, as you have shown us. So prevention, fault detection, prevention, and so they are augmentation, they augment a pattern, as per my little knowledge. Anyway, so thank you, yes. I have given a very short time, like 12 minutes to be precise, so well, I have used up some of my time. Thank you very much for inviting me to this talk. My name is Binish Tanvir, and I am Associate Senior Lecturer at the Blekinge Institute of Technology, Karlskrona, Sweden. Together with my group, I am presenting this paper, An Approach to Align Socio-Technical Dependencies in Large-Scale Software Development. So without any further ado, let's begin. So, as with the context, as we know that large-scale large organizations are adopting agile methods to seek advantages as promised by methods at the small scale. For example, shorter lead time, increased quality, value to customer, and so on. However, with the scaling, it results in exponential growth of dependencies, which, among other challenges of scaling, as we see, is erupted. Now, as to show you this view of a large-scale, for example, organization, if I split the view into 2 halves, on the right side you see I put the organization, which essentially is composed of social structures, teams, policies, and their task dependencies, whatever. And on the other side, on the left side, I have the architecture, which has the technical structures, code, repos, test cases, everything which the team essentially is working on. And this is how I say, okay, these are the social structures in organization side and the technical structures on the architecture sides. And in between lies these socio-technical dependencies, meaning that both the sides influence each other. You cannot change one side without affecting its counterpart. And as a result of scaling, we see that these socio-technical dependencies also increase. And what is the problem with these enhanced socio-technical dependencies is because they have the potential of introducing more waste than value. So what kind of waste we are talking about? Essentially, if we talk about in lean terms. So for example, defects, delays, handoffs, whatnot, and so on. So they have a more potential to introduce more waste as compared to when we are talking about a small-scale organization. So why it is important to deal with these dependencies? It's because for the very reason the companies are adopting these methods, they won't be able to achieve it because of these problems. They cannot deliver value, be fast, or stay competitive. Now, in order to handle this, what can we do about them? Now, the thing is, okay, let's identify those problematic dependencies on either side and try to remove them. But this is not as straightforward a case. Like I say, and of course from Conway's law we know, that both sides influence each other. So we have to take in account that when you change one side, it has its repercussions on the other side. So there is no holistic approach, including our these scaling methods, that take care of both sides together. That's why this approach that I'm trying to express here is to align socio-technical dependencies, and while aligning them, use it to improve and identify and remove the wasteful dependencies. Now, how will we do that? In order to explore that, we did a study with our industrial partner. So this large-scale company is an ace in, say, banking sector. The domain is banking sector. They develop solutions for financial solutions for their clients. Now, it's a large company. They have monolith architecture as their legacy system. They are still maintaining it. They are not transitioning it towards microservice architecture. They also have microservice architecture for some of their systems. Now, we were doing research on another topic with this company, which chose to be anonymous, of course. So, but what they did was they were having some troubles, like they mentioned to us, okay, we were having lack of clarity and ownership of responsibility among teams. There was not a centralized decision making, so teams were pushed decisions from the management in terms of architecture as well as development and from customer side and everything. So they were pushed. They were not really autonomous in that sense, or they were not really having clarity on their responsibility assignments. As a result, they were also having delays in task delivery and so on. So we were not the part of identifying the problem. However, they initiated proactively an initiative in which they reorganized their social structures only in order to enable team responsibility, assignment, and autonomy. So in pursuit of this, they initiated a change, and then they asked for support, our support, to make it more effective, this initiative. Now, okay, well, they have kind of proactively taken this initiative, and they are in a process where the initiative has partially taken effect. So the things are defined. Now they have kind of draw a line between their production unit, in which all the businesses and long-term visions and all these business policies and strategies and customer side, that is taking decisions on that side, and the other side is development. They still are lacking the architecture module because there is no team for architectural decisions. They lack the overall picture of architecture. That's also a part of our problem. Now, perhaps they wanted to kill all these problems with one stone, and they said, okay, let's reorganize, and perhaps with that we can achieve some autonomy and so on. In our research and perspective, the probable outcome of this initiative might be that the expectation of responsibility assignment might not be achieved. However, misalignment definitely will occur, because they only have considered the social structures without considering what the impact might be on the technical side. Now, the stance that we are taking here is, it requires more than just emphasizing a modular structure, so to say, or introducing architectural principles, or operationalizing these microservices architecture, or examining the team inner structures and everything. Because it is also imperative to take care of those socio-technical dependencies which are hindering the autonomy in first place. I'm not really talking about the autonomy of teams towards architecture. We have had this talk in the afternoon, early afternoon, about how to enhance team's autonomy with respect to architecting. But anyway, so I'm abstracting it up. I'm not really concentrating on one part of a problem. However, we could see how we can deal with this problem of giving the teams some autonomy while taking into account both sides, the social side and as well as the technical side. So in the study, what social technical dependencies are refraining teams from realizing their responsibilities and hindering autonomy? So we did some data analysis. So we had some kind of interviews. We had their perceptions of what kind of things they were thinking when they were doing these team reorganization. And when we looked at the data, we came across, okay, there were compile and runtime dependencies, there were task dependencies among the technical structures. This is a short script of how we extracted those dependencies and identified some potential problematic cases. Now in this case, if you see, as an example, if we have team A and team B, the bubbles show that they are components owned by team B and team A respectively, and the sizes show the number of dependencies. we have compile and runtime dependencies and task dependencies. Now, in the first case, we see the potential cases. In X case, we see that although the component is owned by, theoretically, team A, but it has a lot of dependencies coming in from team B. So most of the contributions are coming from team B side, although the ownership is with team A. Now, this can be a potential problematic case because if team A has to sign off on code reviews or something, they still will be waiting for team B to finish the tasks, which are they doing it, and maybe, because why I said potential cases, because this is just identification, a very preliminary results that we have, but we still have to confirm them with the company. Now, if you see on the Y side, this is also a problematic case because it has a task dependency. So in the ticket, in the Jira, we have more than one component appearing in that ticket, but there is no corresponding compile time or runtime dependency. That also raised one alarm towards that. Now, initial analysis of the company data, we investigated 272 components belonging to 37 teams. We identified about 5,779 such dependencies, out of which 1,055 are found to be potential problematic cases. However, we still need to go through them and ask, okay, which one these could be potentially problematic or actually problematic, and how we will do that, that's another ongoing work. Now, with this, the thing that we got out of this, the results that when we presented the team, so at least they were able to identify that we have correctly identified the problematic cases in a sense, specifically with the ownership thing. So if one team is owning, at least theoretically, the other team is actually contributing it. So that is on paper, or at least on our analysis is correct. The rest of the things, of course, we need to do a root cause analysis with them, identify which are the inter-team, intra-team dependencies, and so on. So lessons learned from this short study that we did is that actually we need to aware the teams before they actually start taking such initiative, that what repercussions they might have to see if they just consider one side of both the structures. And this, once we have identified, at least for this case, so it's really at least for this case that we have, but what we can do, we enhance this approach and enable the teams to be able to identify such dependencies by themselves. This is an ongoing research, so we have to differentiate now between inter-team and intra-team dependencies and how it affects those actual, so to say, wastes. And we will like to see, subjectively, we have known that, okay, these have problems by the company, but what it means objectively. So we really need to measure, we really need to define such things, and we evaluate them. For example, delays, defects, are they really being affected with these dependencies or not? So such kind of questions we really need to answer now. I think I'm over my time. Thank you very much, everyone. Thank you.
Because I was wondering that maybe you studied this as one company, so I was wondering in the room now, being on the industry day, whether some of the audience would have some more examples that they can, where they can relate this experience to, which probably for you would be interesting to see and to discuss.
I also have a question for you, but of course after you.
Maybe we can both and see.
Yes, so of course, I mean, this is just one case. Obviously, we cannot really generalize on this, but as we go, we can introduce a more better approach, what kind of dependencies we need to think of and how we can apply. But the real question is, what does it really mean, for example, in a microservice architecture? So can we simply shuffle the teams and we go on with that? Because in morning when I wanted to ask a question, but our colleague, he already admitted that it's hardly the case that any service or any module is solely autonomous, strictly autonomous. I mean, they are known to have autonomy or modularization, but it's hardly the case because somehow there are cross-cutting concerns where the teams have to be dependent on one way or the other, be it components, be it services. So what would it really mean? Simply shuffling the team structure, would it easily translate the services and make them autonomous? I'm really struggling with that. I don't really know. Thank you very much.
Yeah, let's see whether we have some opinions on that.
You can only if you have it. You could do that only if you have
required predispositions set up, and that is that every team is using the same language, programming language, and has the same way of structuring things and organizing things. That way, you just, give project to another team, they continue working on it because it's all the same, regardless of which project they're working on. I mean, it's harder because of the knowledge of the project itself, but regarding the code, programming, everything else, not a big deal. However, that is rarely the case.
So if I repeat, I mean, so there have to be some kind of preconditions as to say if we have these conditions met. And I think with your answer, the initial investment or upfront investment would be the knowledge. So basically what the other team has been working on and what they have been working on. So like our colleague said in the morning that we have to communicate. So maybe these boot camps or something like that. But when we come to this part of problem, when they say that we don't have any architecture team, we want a centralized overview, what can be done in the overall architecture point of view. The answer was also how to communicate, and specifically the reasons of these decisions coming from the organization and the reasons behind it. So I think this is also one answer to my own question as you asked. Thank you very much, everyone.
Thank you again. So let's thank the speaker again, exactly. Thank you. So now if somebody else has an opinion or insight, maybe you could raise your hand now so that you can see whom to ask during dinner while we are here preparing the next presentation, which will be online. So it's Eduardo, I see already. So could you share your slides?
Yes.
Oh, we hear you perfectly. Okay. Okay, then please go ahead.
Okay, so thank you very much for listening. I'm sorry not being possible for me to be there with you, but thanks a lot for the opportunity to make the presentation online. So this work talks about the impact of remote work on architectural decisions. So we did a case study in a startup company, and this is, I'm from University of Bolzano, and this work it's from a master student from Brazil, André Paris. Okay, so let me. Okay, so talking about a little the context we have today, we have many companies adopting remote work indefinitely, not because of need, but many of them have an experience during the pandemic and decided to keep this way, at least supporting a hybrid model, right? However, we know that architecture decisions depend a lot of communication, right? Today we're talking about the importance of these communication skills and how this process can be highly impacted by when these decisions are discussed and made online, right? So that can have a highly impact. And when I hear things like this, my first reaction, and maybe from who works with research anyway, it's like, really? They are really impacted or not, right? So then we decided to investigate, so try to gather a little bit of evidence of this. So we did a case study in a software startup to investigate how being remote affected their architectural decisions. So let me, okay, so I will talk a little bit about the company, right? It's a healthcare startup from Mexico. All the team work remotely. It was created in the middle of, in June 2021. I think I don't need to say what was happening in the world at this moment. It has 60 employees, 14 developers, and they start working remote from the beginning. So that's, I think it's an important point, because I see many works talking about migrate to remote, but in this case they already started remote. So I think this is important contextual information here. And I think another important thing is that they have this information security certification, because in their field it's important to have it, and it kind of requires a lot of personnel for that. So meet the team, right? So this is the team they have there. So 5 backend developers, 3 product managers, 3 front-end, 2 tech leads, 2 UX, 2 mobile, 1 quality assurance, 1 IT manager. So you can see that they have, even being a startup and being like a new company, they do have teams with well-defined roles, right? So this is basically also giving some context on their application. So they have this patient app, a doctor portal, and a back office portal for 3 different kind of stakeholders. So basically 3 applications. It has these 2 security layers, and then there are some APIs that the applications access, and behind we have some serverless applications, right? So this is how the decision process happen in the company. Let's say talking to let's say the person that leads this thing. So when a new feature is requested, the developer first kind of figure out how it's going to be developed in the architecture. In case it requires some kind of new services, providers, or any changes in the database, right? They talk to the software architect, which is one of these tech leads. In case, let's say that's no requirements of new stuff, the team can decide that independently. In case this request needs some kind of budget to be developed, then the co-CEO needs to approve the budget. So basically, this is like the decision process they have, right? So giving this context, right, we have these 3 research questions in our study, like how this decision-making process was impacted specifically for the architecture by the remote work, how uniform was the view of the team members about this decision-making process, and how these architecture decisions were disseminated and accessed by the team members, right? So what we do, we did some questions about the participant profiles. That was a survey. These are multiple choice questions. We also did these some open questions about then the research, about the research questions. We invited the 14 developers to participate, and 10 of them accepted the invitation. You can see, like, based on the participant profile, that basically we have like a more senior profile. So they are developers with experience that have also previous experience, because the company is recent. So I believe we get some answers from some experienced professionals. Okay, so about the decision-making process, we have 5 of them has a positive impression that it impacts positively, 3 of them negatively, and 2 of them don't actually have an opinion or don't think it changed. So this is one thing that one of them say, that they said that this decision depends on the impact that have on other teams, on other people. When it's limited to the squad or something that can be has an internal impact, they can define in this way. But then when the impact will affect other teams, they need to talk to the leaders and get everyone involved. So it's basically they define the dimension to see who needs to get into this discussion, right? One suggestion we had from, I think, two of them, if I'm not wrong, is that, we should involve everyone in the meetings that we make decisions. However, we know that that has a cost and the team is not small, so that of course will impact other planning, other activities, so might not be a viable solution in this case, right? About the second research question about how uniform is the view of the team members about this decision-making process, we have one person that mentioned that it was made by an architecture team and that does not exist internally on the company. Another one mentioned the participation of the PM, which actually is not involved in this kind of decision. So we kind of figured out that based on what they said, this vision on how these decisions are made are not uniform, and some does not even correspond to what happens. Even the ones that actually relates to the process, some of them has like partial views of different parts. About the third research question about how the architectural decisions are disseminated, we asked them if they believe everyone is aware of all the decisions made. Only 60%, in the sense 6 of them say yes, and the other 40% believe that not everyone is aware, which is kind of a little bit concerning. And actually 9 from them say that they don't have actually let me try to explain this better because might pass the wrong idea. The thing is that they don't think that being remote kind of affect the communication, but they think that let's say this communication problem, maybe not communicating the decisions. Let's say it's a problem on how they communicate, independent of being remotely or not, right? This lack of communication, it is a problem even when you are in presence.
I'm sorry, I don't have a discrete way now of saying that time is up, so could you please conclude?
Yes, I'm sorry. So yeah, I'm finishing. So we have some answers about how they find about the architectural decisions. One said it's through Slack channel, another one mentioned in the meetings, the other one in the requirements, so they have these divergent visions. So some lessons learned, even for the company that get after this study, is to make everyone aware of this decision-making process, how it works and who participates on it, and also use a standard channel when someone wants to know about these decisions that not everyone participates. It's important to have this good definition where they can find this information, right? And I will just let something for you to think about, right? Of course, the remote work affects how communication is done, but are these problems we found in this case actually specific because of the remote work, or you can also see this kind of problem in when people are working in presence? So I leave you with this reflection, and thank you very much.
Thank you, Eduardo. I don't know whether you hear the applause in the room, so there is some questions for Eduardo, and now we really have to use the microphone so that he hears us.
Okay, yes, I hear you.
There was one online, I think.
Oh, one online question?
No.
Thank you for the great discussion. That's good. Yeah, you mentioned at the end a question that I also was having, whether this is now specific to the remote situation or or just in general for sharing architecture knowledge. And maybe, I mean, the difference of the remote situation is that one doesn't have the personal communication in presence. Was there anything in the discussion with the different people relating to something that is really about physical closeness, let's say? Maybe one thing that in a book, Culture Code, maybe some know it, there was this hypothesis that people need physical distance, low physical distance or physical closeness to build trust, for example. So that could be one keyword where it would be interesting to see whether that was mentioned an issue or so, or really everything was more about sharing knowledge in general.
Yeah, I think like in this case, like the team started remote. So given the global context we have at that moment. So and let's say it's a health company. So I think that the team kind of get into it. Actually, they told me that they talk a lot with each other, especially with the ones they are close. So I don't really think that in this specific case, it affected the trust among each other.
Okay, yeah, that's interesting. Maybe then also a case to look for companies who try to go more remotely. But yeah, let's thank the speaker again. Thanks, Eduardo. And now let's move on to our last talk of the session today.
Okay, thank you very much.
Yeah, just in the meantime, so good evening all. First of all, it's a great pleasure to be here to present this. I did my PhD postdoc in dell'Aquila, so coming back to dell'Aquila is really great, and I hope you are also enjoying dell'Aquila, right? So my name is Karthik Vaidyanathan. I'm an assistant professor at the Software Engineering Research Center, IIIT Hyderabad, India. So this work is basically a part of the journal First Track. It was published in the IEEE Software, November 2022 edition, as a part of the AI Engineering Special Issue. And of course, as you can see, the title is about Agile for Machine Learning Systems. So MLS means Machine Learning Systems. So this was a joint collaboration with Henry Muccini from University of dell'Aquila, then Anish and Reggie from Founding Minds, so which is the company in context. So throughout the conference, even today's keynote, it's always been ML everywhere, right? So it was like water everywhere. Now it's about ML everywhere. But the important question that we often miss is, we talk about ML for software engineering, but we also need to think about how do you engineer ML systems, or how do you build ML systems, right? And one of the important aspect of it is the process aspect, right? What kind of development process you can follow to build an ML system, so that of course, you can do it fast, or you can do it in a more reliable manner, because we all know about the uncertainties that ML brings into the table. And we know for a fact that, traditionally for developing a software, we have this nice agile methodology. We have been talking about this as well throughout this conference, right? And the idea was all about, you plan, you can continuously and incrementally, deliver your software to the customer, and okay, great, the pace of development increased, companies were happy because the money also increased. But now enters ML, and the workflow of ML is completely different, right? It has a very exploratory nature. Often what happens is, you start with some data, you build some model, and then you realize that, oops, you know what, this was not the model I'm supposed to build for this kind of data. Let me go back and fine tune, and in the process you might change the model itself, you might change the algorithm itself, and it can disrupt. Right? And now the challenge now is, how do you build an ML system? Because where you have ML models, you have to take care of data, and then you have also software components which are integrated with the ML model, right? So that brings in this question of, can we develop ML systems then following agile methodology? So can we keep the principles of agile intact, and then maybe increase the pace of development of building a machine learning system? And this is exactly, by the way, this was not just something that we randomly thought. So we had this company, Founding Minds, and this is a company in India. By the way, it's a small, medium enterprise, right? It's not like the Netflix or the Amazons. I'm talking about a company with 200 or close to 200 employees, and they started in 2008. And they have been an agile organization since 2008. And what happened is, Apparently during the COVID, that was the follow-up of the kind of the talk that was given before. During COVID, what happened? Many industries, especially in this domain of financial transactions, they had to, anyway, of course, switch to work from home. Now, what happens is there are support engineers who are working in these companies, and they are usually supposed to work in a very secured workplace. So they are not supposed to carry their mobile phones, or they are not supposed to, take photos of whatever credit transactions or whatever. So this was already in place in most of the development centers. But when COVID happened, they had to go back home. Now the question to the company is, how do you enforce these kind of secure workspaces when people or when employees are working from home? And this, these companies came to Founding Minds and said, can you, develop some kind of a service for us? Because generally Founding Minds is a company that has been working in this retail, finance, and logistics sector. So the clients that approached us, or Founding Minds from that perspective, was having around 1,000 employees at least, and they were talking, can we kind of get a system like this? So that brought, this idea of Proctor, which is the software in context here. So Founding Minds said, okay, let's develop a software called Proctor, and that can provide some nice features like this. So what it can provide is, it can provide a kind of a nice dashboard which shows, what are the activities the employees is involved in, of course without violating, some of the privacy constraints. So what it does is it says, if the employee is using some kind of mobile phone in the workplace, he or she is writing down some notes or whatever, and sends alerts to the admin. Right? And the admins can, control the screens and say that, okay, log that system because they are kind of doing some kind of malpractice, and stop it. Or it can also give you some, threat levels of, okay, what is the current threat level based on the analysis that you get? What is the level of activity that is involved, for instance, in terms of attention level, in terms of stress level, and so on. So all this information are captured. Now, this also means that all this information requires a tremendous amount of machine learning to be done, because object detection models that are running to constantly check if someone is using a mobile phone or taking notes or whatever, check, if the authorized person is working in front of the system using some face recognitions and so on, and also the utilization of the system. So there are a lot of ML in the pipeline. So it is more like a system which has more ML than, typical normal software code. So the question is then, what's the big deal, right? One of the biggest challenges was the technical challenge in terms of how do you manage the latency? Because these models have to run on laptops. I'm not talking about, cloud where you have, you think that you have infinite resource. These are like normal employees. Their laptops may be having 4 GB RAM, and these many models have to run on the laptop. And of course, they have to respect the latency. The utilization of the system cannot go beyond a certain threshold, because let's say that you overload with machine learning models, and this utilization goes up to 80%, they cannot run any other task on their laptops, right? So you want to, kind of take that into consideration. Now, apart from the technical challenge, the interesting challenge is about organization and the people, right? Because the software team clearly knows, okay, we follow Scrum and we know how to do it. But the ML team are like, okay, we don't understand anything about software. For us, it's about Jupyter notebooks. We'll just write the models and, that's it. And they will follow their own methodology. So how do we bring these two teams into the table was a big challenge, right? And of course, there were a lot of components where there was a lot of dependencies on ML models. As I said, if you have to do this kind of object detection, you need to have some client that is running on the desktop, and it has to use a machine learning model, right? So there was a lot of this connection between the ML team and the software team. And you can see that XKCD comic that nicely depicts, what machine learning team thinks about, okay, there is a problem, maybe I'll bring in more data and, improve the model. So how do you do that? So this is when we actually came up with this idea of Agile for MLS. It was, of course, challenging. So what we did was we said, okay, let ML team be, separate team, software be a separate team, right? So now we need to talk with ML team in the language they understand, and of course, software team are used to Scrum methodology, so that is fine. So what we did is we said, for ML team, whatever user stories you have, let us not call it user stories, because from an ML perspective, most of them have no impact directly as a part of a user story. It's more for them, it's all about data and model. So we said, can we kind of change them and say it's more about data stories and model stories from an ML perspective, and from a software perspective, of course, it's more like a traditional user stories, right? And then what we did is, each of these data stories and model stories, we could split into multiple tasks following the traditional ML mechanisms, and we could assign to different people in the team. More than that, we did 3 important steps. What we did is we said we'll have separate stand-up meetings every day. We didn't even say stand-up, it was, right? For the ML team, it was just like a daily meeting. So we said you will have daily meeting, and in each of this daily meeting of an ML team, we included one software team member who will participate in that daily meeting of ML team. Now, why we did that was, we wanted the software team to understand some of the nuances of what machine learning is all about, because you can see there is a lot of research on communication and collaboration challenges when machine learning team and software team work together, because they don't understand each other's language. So this kind of enabled us to do that. So we said, whoever is responsible for integrating the machine learning model into a software component, they should, attend the ML daily meetings. So this happened. Then of course we had parallel software stand-up meetings every day. Now, because of this, software team was able to get some updates on what is happening in the ML team through this member, and also ML team was able to increasingly understand, how machine learning process works and the kind of uncertainty involved. Right? And we also did this idea of a 2-sprint ahead concept. So whenever machine learning team has to develop something, we'll say that, okay, they will work 2 sprint ahead of what the software team is working on. So for example, if you want to do an object detection feature, we'll say that, okay, ML team will work on it maybe 2 weeks ahead, so that by that 2 weeks, software team can come back and they will get that demo API ready. So there was some kind of planning that we had to do in order to ensure that these kind of consistency existed, but in all fairness, it worked out well. So this was and the important thing is we also had a common weekly meeting where all the participants of the ML team and software team, kind of interacted. And this was like very interesting exercise, at least for the first few sprints, because whenever they talk, for example, there was an interesting case. A QA guy comes and says, I am testing this every time. Sometimes it works, sometimes it doesn't work. So he said, okay, that is because of the accuracy. So it's like, why? It is supposed to work, because if you see a traditional thing, it's about you give an input, you get an output, and whatever is the output you're expecting, it has to match the expected output. But in the case of machine learning, there is always this notion of, that kind of uncertainty that exists with terms of accuracy. So it took some time for software team to get adjusted to these norms. And of course, ML team were not aware of this too many jargons of containerization, CI/CDs, and whatnot, right? Great, so this is just an example of data stories and model stories. So you can see that in a data story we split it in such a way that there should be a goal, there should be some source of data, type of data, and an approximate quantity, so you have an estimate on what you need to do. So it's like defining the task in a more modular manner, because usually what happens is you just get all the data that you can from the internet and you say, okay, start training the model, right? Similarly for model stories also, we said, okay, some accuracy, we need at least this much accuracy, and maybe what kind of data you want to be trained on and so on. So this information is captured in a model story. So with this, we were able to come up with this high-level view of Proctor. So all these decisions were not something that we had upfront. This all emerged through these processes. We had a lot of interactions, so every weekly meeting, there will be some changes. So one of the interesting things, just to give an anecdote, is we had this question of whether we should go for a kind of cloud versus edge, right? That was a typical example. So whether you do all this detection on the cloud, or you should do it in the edge and then send something to the cloud. So then we came up with this combination of some monolithic architecture on the edge, then there is microservices behind, and then also some serverless functions for cases like logging and something where there is no much intense activity, right? So all this, what I want to stress is this kind of methodology enabled us to continuously increment the architecture, and at some point we said, okay, this is working, and this has kind of taken into consideration many nuances. And yeah, so then we, of course, as what we do, we had to do this validation study. So we said, let us send these questions to all the participants involved and see what they felt about using something like this. Right? And we got some interesting responses as well. Of course, not everything were positive. We also got feedbacks like they wanted to improve this methodology as per se. But the important thing is, for example, the first thing that said that every sprint the models kept improving. So the API was intact, but behind the scenes they could improve the model because somehow we said that, okay, the ML team will respect the API, but they can probably change how it internally works. The second thing is about the software team became more and more aware of the gray areas of ML results, because this was very important. We can think, okay, it's very, it's a very common thing. But trust me that in most companies, this ML people are from different background, like astrophysics or biology, or even from electronics or electrical engineering. They have no idea much on software, and even the software people maybe are not trained enough to understand about machine learning, right? The final thing is also about the periodic retweaking of the model based on requirements. So kind of it helped to keep this data drift in check, because every time there was a release, the team could actually see the real data and see what is the effect, and based on that they could retweak the model, right? And this kind of helped to keep the data drift and model drift in check. Great. So what are the lessons learned and key takeaways? Of course, Agile for ML opens up new possibilities. I don't want to say that there are no gray literature on this. There are some gray literature in terms of Medium articles or some blog post about Agile for ML, but they talk about Agile for just you building machine learning models, not from a systems perspective. We are talking about how do we integrate software and machine learning, right? The second thing is about, we did find that there is going to be a better communication and collaboration. So this could be one of the possible solution towards how do we improve communication and collaboration in building machine learning systems. There was, of course, better handling of uncertainties. And then we really felt that you can make informed decisions, because every time you have every stakeholders involved in these weekly meetings, the architects could get better understanding of, okay, what is happening, and then what kind of decisions to take, and kind of talk about the trade-offs. Right? But the point is, we need more dedicated tools, because we were kind of customizing Azure DevOps, so the company was using Azure DevOps tool, so we had to really tweak in those to make these kind of things happen. But I believe that in future we'll have more dedicated tools towards building machine learning systems and using Agile. And there was a comment, interestingly, when we submitted this article on why don't you go for cross-functional teams. Of course, that is the way ahead. Probably we'll have software and machine learning team, members working together, but it is not an easy task, because it will take some time. So we think that maybe towards, or in the near future, these kind of methodologies can help towards cross-functional teams. Great. So with that, just want to say some points. The story so far, Proctor was released in 5 months with active users. We were able to give it to the clients. There were more than 6 different types of machine learning models, deep learning models to be more precise, with the utilization much less than 20% of the CPU. And we believe this is just a first attempt to make this collaboration smoother. And we know that there are a lot of things that needs to be done. There are a lot of places where we need to improve this methodology. And we also believe that this can serve as a big boost to the architects involved in terms of Agile methodology. The way ahead, I personally feel that the IDE team and the notebook team, as I call, need to collaborate more, which is the software team and the machine learning team, right? And Founding Minds has been using, Agile for MLS across projects, but we want to experiment with multiple projects. And also we want to extend this possibly to some of you. If you are building some ML systems, maybe we want to try, can we incorporate Agile in this? And as a community, I believe software architecture for ML requires much more attention. So towards this attempt, we are organizing this workshop, SAML, Software Architecture and Machine Learning. It happens with ICSA, hopefully with this year as well. And there is also a Dux tool that is coming up on software architecture and machine learning. So with that note, thank you, and I'll be happy to answer your questions. You can check the QR code for the article. Thank you.
Okay, as we have plenty of time until the buses are leaving for the dinner, we have plenty of time for questions still. So, what are your questions?
Okay. Hi, thank you for the nice presentation. I am just wondering about, for Agile methodology, we usually use some tracking system like Jira, like for user stories. So for the data stories, what did the ML guys used?
That's a very good question. That's what I was saying. We need more dedicated tools. So we were using Azure DevOps, which is the tool that the company was using. It was having user stories concept already, because it's very kind of custom-made Agile tool. But for model and data stories, we had to put in the notion of tags. So it allows the tags. So what we did is we used tags saying, okay, model stories, data stories, and with these tags, we were able to filter it out. But of course, it was not easy. As I said, we need more dedicated tools. Hopefully, this will be the next works that will come up.
Okay,
thank you.
There's a question right behind you, thanks.
Okay, thank you for your presentation.
Thank you.
One aspect that when we talk about Scrum or Agile approaches is the idea of the business value of the story, of the user story. You didn't refer about business value here. So do you assign some business value to your data stories, or how do you relate this, for instance? Because the business value is important for decide what is the next sprint. And probably it's easier to do it when we have something that is more deterministic in the sense because you define the scope and the time that is going to take.
Great.
But
so that
now,
is
introducing these stories where you deal to more non-deterministic, so it's much more difficult to estimate the duration, for instance, of the sprint.
Great, thank you for that question. So, of course, this was also one of the questions that we got. So, I'll answer in terms of story points if that may feel intact, because what we did was, for each of these data stories and model stories, we had assigned some story points. And of course, assigning story points to a data task or a machine learning task was not easy. So, we did some heuristics to do that. So, what we did is, let's take an annotation, right? For doing object detection, you have to do a lot of annotations to train the model so that they can detect that something is a mobile phone or something is a notebook. Now, each annotation takes at least 4 minutes to complete. So we have this data on this. Now, based on this, we estimated, okay, each takes 4 minutes, so let's say 1,000 images is going to take this much time, right? So based on that, we were kind of doing an estimation, but of course, this is not the best estimation, but this was something that we could measure. And also for the model part, what we did is, let's say we want to build a deep learning model. If once the machine learning team, what happened to this? Okay, so once the machine learning team got an idea on we need a kind of a deep learning model, we used to have discussions with them, initially the ML architect, to decide, okay, these kind of deep learning model, how complex it is, and then based on that, we used to estimate points. So this was some basic stuff that we did. Of course, there are a lot of rooms for improvement there. Thank you for the question. Yeah.
Yeah, thanks for the talk. I have a short, maybe cheeky question. So you created this process to incorporate machine learning in an agile environment, and you said we need more tools to better incorporate it. But the Agile Manifesto says we have individuals and interactions above or over processes and tools. So how does this work? Does this mean that machine learning isn't agile?
Okay, by definition, machine learning is not agile. That's the point. But I understood your question. So from that perspective, what I'm saying from a tool is more from a project management perspective, not from enabling agile itself. It was more from a project management perspective. How do you manage the project? But also consider this, that different companies have completely different notion of how they implement agile. So there was a work by, I think, the team of Rashina from Monash University in Australia, where they interviewed like a lot of practitioners across industries, and what one considers agile versus what other considers agile was completely different. And they even said that, what do you think from Agile Manifesto and what is happening in practice? There is a huge deviation. So, of course, the tools that I was talking about was more from management perspective than from enabling agility in that sense. Yeah.
Yeah, then one last question. Well, I'm getting the map already where we have to go next, and during that you can answer that last question. Okay.
I just was wondering, because when you generate user histories, you have some guidelines to make sure of the quality of the information that you're presenting. Did you use something like that for generating the data model histories?
No. As of now, we didn't do that. So this is probably something we can do, because of course this had a very stringent timeline, so we had to move very fast. So some of these things we couldn't incorporate, but that's a good point. Thank you.